Tyra subscribes to an online gaming service that charges a monthly fee of $5 and 25 cents per hour for time spent playing premium games. Which of the following functions gives Tyra's cost in dollars for a month in which she spends X hours playing premium games? So whenever I have a word problem like this, and I can look down and I can look at the answer choices, I know that this is a linear, it's like a modeling a linear equation word problem. Okay, so if you want more of these linear equation word problems, is the section to check out if you need more practice on stuff like this. Linear equation word problems is your friend. Go look those up. We have a content video on that. We have a download on that. And this is also a Khan Academy title. So if you need even more practice, there you go. Whenever I have something that I know is a linear equation, what I'm going to do is think about my slope-intercept form. Remember, slope-intercept form is y equals mx plus b. Okay? B is always going to be like my fixed cost. So if I have a monthly fee of $5, that's probably my B for 1 month, right? And then 25 cents per hour, that's probably my M. Remember, whenever we have per indicates divide or a slope or a rate, okay? Rates and slopes are usually the same. Whatever the M is in a word problem, it's usually a rate. So when I see 25 cents per hour, I know that's a rate, and chances are that's going to be my M, okay? For time spent playing premium games. And this is how I figure it out, okay? If I do 25 cents per 1 hour, then what happens is if I multiply this by some number of hours, this is going to give me money, okay? And I know that because the hours will cancel. And this is just dimensional analysis stuff. I go over this in units, rates, and ratios. If you want more on how to set up the rate and how the per works and all that kind of stuff, I go over that in that chapter. It's really cool and wonderful, okay? Now I'm gonna add my B, my fixed charge, which is $5. So my cost per month is going to be my fixed charge, or my B, my $5. And then that's money. And then I want to make sure that this label matches this label, okay? So even though I can tell you most of the time, 90% of the time, the M is just going to be the rate, I have to be careful because on really tricky SAT problems, sometimes they'll give you the rate upside down. They'll say hours per dollar or something, and then you can't just stick it here. You have to flip it upside down. So that's why I always double check that whatever I have here, this is some number of hours, and it says she spends X hours playing, so then that works. Do you see how the labels match up and everything works, and then it becomes money? Which of the following functions gives Tyra's cost in dollars, and cost is C of X? So then this is going to be C of X, and that makes sense, because if I add this amount of dollars to this amount of dollars, that is going to give me a cost, which would also be in dollars, right? So this is my equation. I'm going to have 0.25x plus $5. I want to make sure that it's 0.25x plus $5 and not 25x, because this would be negating the fact that cents are different from dollars, right? This is dollars, not cents. This is cents, not dollars. So those are not in the same language. That's why I have to put this in dollars, which is 0.25. And our answer is C. If you picked a D, you made the mistake of just using 25 as 25 cents and not thinking about the fact that this needs to be in dollars. If this is in dollars, and if this is in dollars, do you see over here it says in dollars? So we need all of those things to match, right? Dollars, dollars, dollars. And you may have not seen that. Here we've mixed up where to put the 5 and where to put the 0.25. So this is our fixed amount, not our rate, and so it doesn't go there. And we can't just add together the 5 and the 0.25. That's just not going to happen, okay? And there you go. That's how we set this up. So hopefully that helps you guys out. Again, this y equals mx plus b form is really common on word problems. You have to just know what to look for. This is generally, again, the rate. This is the fixed amount. And then you just have to always set it up with your dimensional analysis and make sure that what you get here is like same label, you add these two same labels together, and that's the same label as this. So that label for this one was dollars, right? We got dollars and dollars and dollars. It could be anything though. It could be envelopes, envelopes, and envelopes. It could be any other label. It could be inches, inches, and inches. But that's the thing that you have to check. You have to plug the stuff in, make sure the right stuff cancels, and that you get the right elements. Again, if you need more help with this per stuff, with this rate stuff, with that dimensional analysis, units, rates, and ratios, in-depth content is where I want to send you. So I'll just write that down too. Units, rates, and ratios. And this is an in-depth content, and this is or what we call skills. This is a skills video that we have that I would check out if I were you guys, if you want to build skills that will help you in this. And then this is just linear equation word problems. Cool, cool. All right, number 2. A grocery store sells a brand of juice in individual bottles and in packs of 6 bottles. On a certain day, the store sold 281 bottles of the brand of juice, of which 29 were sold as individual bottles. So I'm going to subtract 29 from this to just see how many bottles were not sold as individual bottles. I'm just anticipating that So that gives me 252, right? I could do 11 minus 9 is 2. I could do 7 minus 2 is 5. You can see that, okay? So 252 bottles. This is also calculator, so I could get out my calculator and do that, and that's probably what I usually do. Were sold as part of 6-packs. So now what I want to do is divide that by 6. And I'm just doing all the math here. I'm going to divide this by 6, and what's that going to give me? That's going to give me the number of packages. So that's what that would give me. Which equation shows the number of packs of bottles P sold that day? So I want 252 over 6. So which of these gives me 252 over 6? Well, what did I do? I subtracted the 29, right? That's where this came from. So now I'm just backtracking. So I just like to solve it down myself and then kind of figure out what did I do and which of these is the same setup as what I did. They're not always going to solve it exactly the same way you do, but if you know how to solve the problem, you can kind of solve it down a little bit and then backtrack and say, okay, where did the 252 come from? Oh yeah, that was 281 minus 29, wasn't it? Oh yeah, so that's what I need. A is going to be my answer. Here we're adding, that doesn't make any sense. Here we don't want to divide by 6 first. This is weird, right? We want to divide the 252 by 6. This isn't going to be divisible by 6 anyway. So we can see how this works. The first thing that I wanted to do is figure out the number of bottles that were not sold individually. These are the ones that are not sold alone. Then I take that number of bottles and then I distribute them 6 at a time into a bunch of containers. How do I distribute 6 at a time? I divide, right? That's what division is. So that's how we solve this. I realize that you might not set it up like this and that's the part that's confusing, but just do it the way that you would do it, right? Do it like a normal word problem and solve it down a little bit and then see where did I get this? Where did this come from? All right, and you can backtrack. This is linear equation and function word problems, which I think we may have mixed together, or just word problems. Yeah, linear equation word problems. On the monthly rainfall in Chestnut City. Cue sound effects for rainfall. Rainfall in inches. Month. Okay, whenever I see, just a tip for you guys, whenever I see units, I like to circle them. I like to be aware of them. I like to know what's up. Okay, the line graph above shows the monthly rainfall from March to October last year. So we go from March to October. And according to the graph, what was the greatest change in absolute value in the monthly rainfall between 2 consecutive months? So here's what we're looking for. This is, whenever you have these data problems, this is the most important part. The biggest mistake that people make is they misinterpret what it is that they're looking for. So don't do that. So let's figure that. We want the greatest change in absolute value. That means it can be a change upward or downward. So I want the steepest drop or rise between 2 consecutive months, okay? Consecutive means in a row. That means I can't go from March to August and call that a rise, okay? I can't go from August to October and call that a drop. I can only go from, say, September to October. September to October would take me from 5 to 2.5, right? And I always be very careful when you have these lines that aren't labeled, make sure you label them correctly. This isn't 3, it's 2.5, right? Just because this is one line up from 2 doesn't make it 3, it's 2.5. You have to look at the other label and figure out what it is. So this is 2.5 and this is 5. So that difference is 2.5 inches. And that's what it is. Because it's absolute value just means it's the distance from 0. So that means it can be negative or positive. So this is negative 2.5. That's going to be bigger than this rise, which is 1.5, right? So 1.5 is here, that's the greatest positive rise, but this says in absolute value. So you've got to be really careful to read this carefully and know what it means. And if you didn't know what absolute value means, well, now you know. Absolute value is the distance from 0, and it means it can be a positive or a negative number, and we're looking at the magnitude of that number. That means how far is it from 0? Not necessarily is it smaller, which a negative number would be smaller than a positive number, right? So there you go. Number 4. A rectangle has a perimeter P, length L, and width W. Which of the following represents L in terms of P and W? Okay, so here's what I'm going to do. I'm going to create, I know this can be overwhelming, and you're like, what? I don't know how to do that. I know how to do this. I know how to find P in terms of W and L. Well, that's where you start. So it's not as hard as it looks, okay? And I want L in terms of P and W. So all this is a manipulations problem. If you are on our course, this is isolating quantities, or possibly structure and expressions. But you're going to find similar questions to this in isolating quantities. That's what this is called, isolating quantities. And this is sometimes also very similar to what we call structure and expressions. Okay. So if you want more that are similar to this, go check out these 2 packets and videos. that we have on our course. Those are under content. These are our content areas that coincide with this. So we have perimeter P, length L and W, which the following represents L in terms of P and W. So I first do this, and now I want to isolate the L. Okay, so we get P minus 2W equals 2L, and then I just divide by 2. You see, divide by 2. This is just algebra, and all we're doing is isolating the L, and then I get L equals P minus 2W over 2. Now, there it is, and we're done. If this weren't there, then I would have to manipulate this a bit more, right? I might make it P over 2 minus W. That would be another solution. So if you got all the way down here, maybe you just went too far. I always like to stop at a certain point when I start to see things that look similar and see if that's there. If it's not, then I might have to manipulate a bit more. If you still can't figure it out, the other thing you can do is you can use these and you can go backwards, right? So I can make this 2L equals P minus 2W, right? And then I could work backwards. So that's another way to deal with isolating quantities problems in case you get stuck. But hopefully you guys understand that C is the answer. It's not as hard as it looks. The other mistake people make is they confuse perimeter and area. Don't be that person. Learn your perimeter and area. Those we're going to go over in our in-depth content on geometry eventually. But for now, you should know the difference between perimeter and area. Perimeter is the sum of all the sides, right? Area is length times width. Cool. Number 5, which order pair satisfies the system of equations shown below? So when we have an order pair that satisfies a system of equations, that just means the solution set, and the solution set is x comma y. That's what all these mean. They're just coordinate points, x comma y. And this is the x values, and these are the y values. Some things that I sometimes do is I look through and I say, where are the most original numbers? And I see that the most original numbers are x's. Do you see how the y's are almost universally positive too? So if you really had no idea how to do this, one shortcut way to do it might be to assume that y is going to be 2. And then you could assume that 2x would be 8. And that would mean x is 4, okay? And you could back solve and plug it. That's if you're really stuck and you really have trouble with this stuff, okay? But that's also a good way to check it at the end. That's not the right way to do the problem, though. That would give us answer choice D. I do know, though, by plugging into that A and B cannot be right. Now, if I plug in negative 2, then I get 2x minus 2 equals 6. I just did this in my head, by the way. A lot of you aren't going to do stuff like that, but I'm just showing you kind of how you can check it. Now let's do it the right way, okay? When I see that the differential element is x, I want to isolate my y and solve for x. So isolate to eliminate is the little phrase that I like to use to eliminate. This helps me know how to substitute. When I say isolate to eliminate, I want to get in a corner whatever I want to get rid of. Whatever isn't in the corner all by itself on one side of the equation, that's what's going to remain. And so that's what I will be able to solve for. So I want to eliminate the y because I want to know what x is. So isolate to eliminate, I'm going to isolate this y and then I'm going to substitute. Again, this is just a substitution strategy. So I'm just changing this around. I'm going to add y, right? And then I'm going to subtract 6, okay? Minus 6. That's all I'm doing up here. And then I get this. Everybody with me? I hope so. Now I'm going to substitute in for y 2x minus 6. And I'm going to substitute in right there. So I'm going to do x plus 2 times 2x minus 6 equals negative 2. And then this is just plain old algebra. Really simple, straightforward stuff, okay? 2 times 2 is 4. So that's 4x. 2 times negative 6 is negative 12. And then we have x plus 4x minus 12 equals negative 2. Now we can go 5x minus 12 equals negative 2. And then I can add 12 and add 12. And then we get 12 minus 2 is 10 equals 5x. Ooh, and I get x equals 2. Oh, look at that. This was wrong. So there you go. X equals 2. Now I'm going to plug in x equals 2. I get x equals 2. I get 2 times 2 minus y equals 6. This should be the answer then, but I'm just going to double check it now. And the double checking I usually do at the end, by the way. So this is 4 minus y equals 6. And then I get negative y equals 2. So that means y equals negative 2. So there it is. C is my answer. You can see again how if I would have used the answers, I could have seen, oh, like if this is right, then the answer would be D. But I don't know if that's right. I could also check for negative 2. And when I check for negative 2, what's going to happen is I'm also going to find that x is equal to positive 2. This becomes plus, essentially, and then that becomes minus. So I get 2x equals 4, and then x equals 2. So you can see that here x equals 2, so our answer is C. But you can see how I can also kind of back solve these, right? So if you were stuck and you had no idea what to do, you can test this, you can test this, you can see what happens, and you can kind of back solve, and then you can put them in there too. Again, though, the right way to solve this is this isolate to eliminate stuff. This is a substitution. Get something alone, plug it in, solve for one variable, and then go from there. Again, I like to solve for the variable that's the most unique in the answer choices. That just saves me a little bit of time. And then if I have time at the end, I can come back and proof it. But because I'm strategic about how I approach it, that saves me time. That allows me to do almost every problem on the test like twice. So there you go. A soda company is filling bottles of soda from a tank that contains 500 gallons of soda. At most, how many 20-ounce bottles can be filled from the tank? First thing to not do, don't just divide 500 by 20. If you do that, you will get 25, and you'll think you are right, but you are not, because ounces are not gallons. So first rule of thumb on the SAT, whenever I have any kind of labels, I like to circle them. We're going to go over how to do these in depth in our units, rates, and ratios in-depth video, which is a skills video. These are under skills. So if you look on the tab on your course, this is going to be under skills. This also relates to a content video, which is units, is the contents. So the practice set on units, and then Khan Academy, if you go and you look for units, this is units. Here's what's going on. We have 500 gallons of soda. We want to transfer that to 20-ounce bottles. The first thing we have to do is put this gallons into ounces, and it's a heck of a lot more ounces than 500 because 1 gallon equals 128 ounces. So if this is 500 gallons, look at how this works. We're going to use dimensional analysis. I go over all the dimensional analysis again in this skills video, but I'm going to go over it really quickly right here. I want gallons on the bottom and whatever the conversion factor is on the top. So I like to call this a conversion factor. It means it converts between gallons and ounces. When I have gallons, I'm going to put the gallons on the bottom so that these cancel. This cancels in the same way that like when we're multiplying fractions and we have a 2 on top and a 2 on the bottom and they cancel. Same idea, but different because it's a dimensional analysis. So we do it with the labels, but we want those to cancel. And then we want ounces on the top. So I'm going to put 128 ounces on the top. And then this is going to give me ounces. So if I do 500 times 128, that gives me ounces. Thank goodness we're in the calculator section, people, because it means I can do this in my calculator. So I can do 500 times 128, and then I'm going to divide this by 20 ounces, right? Because I want my total ounces. How am I going to get how many bottles I can fill? Well, I'm going to take my total ounces, and then I'm going to divide that by my ounce per bottle, right? Per like bottle. There, that looks more like a flask, but pretend it's a bottle. Okay, so ounces per bottle. And then that's going to tell me how many bottles I have, right? Because think about it. Sometimes I like to think these through sort of just with my brain. If I have all these bottles, there's some bottles. Those look like shampoo. I'm trying, people. This is an art class. Okay, so if we have all these bottles lined up, right, and they equal a certain number of ounces, I have to distribute all of the ounces into this, into this, into this. What is that? That's division, right? I'm dividing this among all the bottles. So if you don't know to do division here, if that confuses you, sometimes I like to draw out a picture. I like to think about what's happening. Oh yeah, I'm pouring all of this into a bunch of bottles. What is that? That's division, right? So I'm going to take these ounces, divide it by those ounces. Now this is 25, by the way. If that's easy enough to do, you can do the 0 and 0 cancel, and then 50 divided by 2 is 25. So then we need 25 times 128. I'm going to do that in my calculator. You can also do the whole thing in your calculator, which is totally fine, no shame. I mean, heck, I'm doing part of it in my calculator. I may as well have done the whole thing. 3,200, and it's D. So you can see it's definitely not 25. The other thing that I want you to think about is if you ever have these units questions and you're double checking your second round at the end, I like to double check everything on my whole test on like a second pass if I have time. And if you are lucky enough to have that time, here's how I would do that. I would look at this and I would say, if I'm taking 20-ounce bottles from 500 gallons, this is a boatload of soda. If I'm taking 20-ounce bottles, I'm going to have a boatload of 20-ounce bottles because 1 gallon alone is going to fit over 6 bottles, right? So this is going to be at least like 3,000, and I can just estimate that. So sometimes when I'm checking on the backside, when I've already done the problem once, when I check a second time, I ballpark it and I use estimates in order to double check it, because that helps me kind of wrap my head around the problem and make sure that I'm just in the ballpark and that I'm getting the right answer there, okay? So there you go. This was a units problem. Again, units, rates, and ratios is going to be the skills video that goes with this. You can go check those out and perfect your ability to not make the mistake of forgetting that these are not the same units. Not the same units, people. So if you put A, that was the mistake. If you put something else, I don't know what the mistake was, but I'm sure there was some sort of systematic mistake that you made. Number 7. A car traveled at an average speed of 80 miles per hour. Whenever I have a rate, I like to rate it like this: miles over 1 hour for 3 hours. So instantly when I see that, remember, a rate is a ratio in disguise, and remember, distance equals rate times time. Whenever I see a rate and a time paired together, I'm going to go ahead and solve out for that distance because I probably can use it. My hours cancel, and I get basically 80 times 3, which is 240, right? Oops, I guess this doesn't cancel. It really just multiplies out, which is 240 miles. Okay, so a car traveled 240 miles. That's cool. And it consumed fuel at a rate of 34 miles per gallon. Okay, 34 miles per 1 gallon. Okay, so maybe I actually didn't need that, but who knows? But maybe I could combine these to then figure out how many gallons. Oh yeah, and that's what I need. Approximately how many gallons of fuel did the car use for the entire 3-hour trip? Skills video for this, people, is units, rates, and ratios. We go over all of it. This is a rate, by the way. So the skill is units, rates, and ratios. If you guys haven't noticed, that is all over this test. It's like every other problem is the same scale, which is actually kind of cool because you can kind of study one thing and get through a lot of stuff. But it's kind of uncool if you don't know how to do it. The other thing that you guys can look at if you want more like this, I guess it's ratios, rates, and proportions. So in terms of content, you're going to find this in the chapter that's called ratios, or the download and video that's called ratios, rates, and proportions. Okay, this is a rates problem. So you're going to find it units, rates, and ratios, rates, and proportions. Okay, so 2 different places you're going to find this rates, but it's a rates problem. So if you just remember rates, you're going to be fine. How many gallons of fuel did the car use for the entire 3-hour trip? So now I need to use this and combine it with this idea of 34 miles per gallon. I know this, right? And I know this. How do I turn that into gallons? Well, I can do 2 things. I can either create a proportion, right? If you guys like to create proportions. And the proportion would be miles over gallons equals miles over gallons, right? So I can do that. Or I could use dimensional analysis. If I use dimensional analysis, it looks something like this. I'm going to have to actually flip this upside down. So sometimes we get miles per gallon, and we actually want gallons per mile. And that's what the case is here. So I have 240 miles. I want the miles to cancel. So I actually want the 34 on the bottom. Whenever you have a rate, you can always flip the rate upside down. So just remember that if it's not the direction you need, flip the rate upside down, and then your miles cancel. Boom. Not so bad, right? And I get 240 divided by 34. Okay. And this becomes 120. Oh, let's just do it in our calculator. Let's just do it in our calculator. Now it says approximately. This is the next thing I'm checking for. These don't look like they're going to divide evenly. And so then I'm looking for some approximate language. Whenever you need to approximate, you want to look for that approximate language. 240 divided by 34. I can tell that those don't go into each other perfectly. 7.058. So approximately 7 gallons. 7.05. We need a little more than 7, but it's about 7 gallons. Rounded to the nearest gallon. Fine. Cool? Cool. So I'm just going to put 7, and we're done. Ta-da! So how we solved this? I used my dimensional analysis. I set up my rate as an equation in disguise, miles over hours, and multiply by hours to get back to the miles. I do the same thing again with miles per gallon. I can either use a proportion or I can use my dimensional analysis again, but this time I have to flip my rate. Don't be confused by the rate flipping. Don't just always take the rate and multiply it by whatever you have. You might have to flip it upside down. So just make sure that if you're doing dimensional analysis, this and this cancel, and you're going to be good. And that equals about 7. Do approximately equal to. Ta-da! Yay. What is the slope of the line in the xy plane that passes through the points blah? So if you have a calculator, my favorite way to do slope problems is to use a calculator program. We have actually a slope calculator program that you can download from our course. I'm going to show you right now where to get it. You're going to go to courses, and I'm going to show you how to do all of it too. So we go to our downloads cloud right here. If you saw where it is, if you're on any math video over here, you just click on that, and then you scroll down to the bottom, and right here, SupertutorTV, SAT, TI-84 programs. You can download those. They work on TI-84 and related calculators. I can't vouch for how they're going to work on like a TI-89 or a TI-83. We think they might work. Depending on what edition you have on the calculator, the display might be a little bit different. If TI happens to update their calculators over the years, or you might have a slightly different edition, there might be some issues. We don't guarantee that all these work, but we have them there for you if you want to use them. and you can download those. If you want to know how to put them on your calculator, there are videos for that too. Right here, TI-84, downloading calculator programs. You can add this to your study list if you want. You can just put a little heart on that. Or calculator overview. You can check out these other calculator videos, calculator overview and calculator hacks. If you want some more calculator tips. And my favorite way to do this is with a calculator program that literally solves this all out for you. Remember, if you have something like this, you can always make it into the decimal form, which here would be -2.5, or you can just put it in parentheses as you enter it and do -5 divided by 2, right? Put it in parentheses as you enter it into your program and you'll be cool. Okay? So that's how to do it with the program. I assume that you guys can watch those videos, figure all that stuff out, and do it that way. That's my favorite way to do this. But I'm going to do it right now the old-fashioned way, just in case this comes up on no calculator. This is the calculator section, but sometimes these come up on no calculator. So you need to know how to do it the slow, old-fashioned way too. And the way that we do it that way is y2 minus y1 over x2 minus x1. This is just the slope equation. You should have it memorized. What does that mean? Well, I sometimes like to write it out like this. If this is x2 comma y2, then this is x1 comma y1. And that's kind of how these work, okay? So we're going to take y2 and y1 and we're going to plug it in right there, just how that is, 4 minus 1, 4 minus 1. Biggest mistake students make is that then they reverse the order. They do this minus this. We don't want to do that. We want to go this direction, right? If I go from here to here, I then want to go from here to here. I have to keep my arrows going in the same direction, okay? -1/2, and then we go minus 5 over 2. Word to the wise, if you screw up the slope equation, most of the time, if you go out of order, like if you go this to this one, the biggest mistake that people make, you will just screw up the sign at the end. So you will definitely get something that's here, probably. Like if this is -1, you'll have 1 there, but the sign will be wrong. So this on the top is going to be 3. On the bottom, remember, minus minus is just plus. So this is 2.5 minus 1/2, which is 2. If you want, you can also do this in your calculator. You can do 5 divided by 2, which is 2.5. And then you can do -1 divided by 2. Or something like that, but I can see that that's 2, so it's 3 over 2. Our answer here is D. Okay, so that's not here in negative form, but B is. So if you put the X's over the Y's and you screwed up the order, then you may have gotten that answer. This is actually kind of a nice problem. You know, it's nice because if you make the most common error, the answer choice actually isn't even here. So they're being nice to you for that reason. But again, I usually just use my calculator and use my calculator program, and then it solves it all out for me. And that's pretty cool, and I don't have to worry about much. And I showed you where to download that. So there you go. Try it out, see how it works. You can go through my calculator videos. Hopefully you'll figure it out. Number 9, dimensions of envelopes, width and height. The scatterplot above shows the widths and heights of 12 types of rectangular envelopes. What is the width in inches of the envelope represented by the data point that is farthest from the line of best fit? So the first thing we have to do is draw a line of best fit. How do we draw a line of best fit? You just estimate it. You see where the clump of dots is, and you just throw a line through that. That's what the line of best fit means if you didn't know that. I realize that a lot of times in school, you're not going to be talking about lines of best fit. It might be something that's a little bit foreign to you. You might not be super versed in it, and that's cool. We just draw our line right here. And then we have height and we have width. And then where's the data point farthest? There's the data point that's farthest from that line. It's right here. So now what I want to know is what is the width? So to find the width, I have to make sure I look at the right one, right? Here's the width. So this is height, this is width. Make sure you don't look at 4, okay? We want to look at 7. So our answer is just 7. If you put 4, which isn't here, that would be the height. Now, maybe you just misinterpreted this, or you didn't know what line of best fit was, so you just picked a number and you had no idea. Maybe you picked, I don't know, 2? Maybe you thought this was the farthest from the bottom? Don't know. But as you can see, this is a really easy problem if you know what line of best fit means. It means just draw a line kind of through the clump of numbers. Don't worry about outliers. Find the outlier. Find the width. Easy peasy. Done. Cool. This could be scatter plots, if you want more of these. Or this could be key features of graphs is very related. So those often clump together. So you might find key features of graphs is a good one to look at. But this is scatter plots above all. This is the number one. This is where we should send you scatter plots. So go try some scatter plot problems if you missed that. All right, number 10. A high school basketball team won exactly 65% of the games it played during last season. This is a percents problem. Which of the following could be the total number of games the team played last season? So this is kind of a hypothetical question that says, hey, if we won 65%, exactly, that means this times one of these numbers has to equal an integer. Okay, that's all this is saying. And I know some of you are like, what? I have no idea. Like, well, how does this even help me do anything? Like, what? This is weird and crazy. Another thing I could do that might help me out is I could reduce this fraction. One way I could do that is I could get out my graphing calculator, my TI-84, and do 65 divided by 100 and then frac it. If you know what I mean by fracking, I mean press the math key and then make sure frac, F-R-A-C, is highlighted and press enter. And it's going to turn it back into a fraction. So what I'm going to do is I'm actually just going to divide this by 5. The other way to do this to reduce it is to divide by 5 on the top and divide by 5 on the bottom. The top divided by 5 is 13, right? The bottom divided by 5 is going to be 20. So this is 13 over 20. So I need this times some number is going to give me an integer, right? Well, this times 22 is not going to give me an integer. I know that much. Because 22 is not divisible by 20. So my first step here is I took my fraction 65 over 100 and I reduced it down into its lowest form. And now I'm going to see if it's in its lowest form, what would I multiply this by to get an integer? And I can see right away now that my answer is going to be 20. So you can see I can do this without a calculator too. With a calculator, you would do this, you can put it in and then fraction it out, and then you get this, and then you recognize that you have to multiply this percent times the total games, and then you have to have an integer number of wins, right? Pretty much. It doesn't say approximately, it said exactly. So this word exactly is really important in this problem because it says that this has to be an integer. Cool? And I can see at this point our answer is going to be 20 because if 20 is multiplied by 20, right, I will get an integer. Now the other way you could do this is you could literally just take 65 divided by 100 or 0.65 and multiply all of these by 0.65, okay? And then over and over and over again until you get one that's an integer. And the only one that will be an integer is B. So another way you could have done it, you can do it really fast in your calculator. If that works for you, that works. It's cool, okay? But remember, of means multiply. So if I have 65% of the games it played, that's 65 over 100 times the games it played, right? Which you can use the answers equals wins. And if you don't know how to approach something like this, my best advice is try to back solve it, right? So there you go. 11, a coffee shop is running a promotion where a number of free coffee samples are given away each day. This is interpreting linear functions, by the way. So if you want more, head over to interpreting linear functions. A coffee shop is running this promotion. The equation above can be used to model the number of free coffee samples Y that remain to be given away X days after the promotion began. So I'm going to start to plug in numbers to try to understand this a little bit. So let's say 0 days after the promotion began have passed. I'm going to have 1,210 samples. Let's say 1 day after the promotion has passed, right? I'm going to let X equal 0, and then I'm going to let X equal 1. So this is my strategy. I like to plug in 0 and 1 and see what happens as I step it up by 1. The other thing that I like to say is whenever I have a slope in a function, I like to step that slope up by 1 and see what happens. So if I plug in X equals 1, then I'm going to have 1,100, right? So it looks like I'm losing 110 samples a day, right? X days after the promotion. What does it mean that 11, 0 is a solution to this equation? That means when X equals 11, that means 11 days after the promotion began, because I have this right now. So this means 11 days after the promotion began. Do you see how easy this is? This is not hard. 0 is Y, and what is Y? The samples that remain to be given away. That means Y equals 0, or 0 samples are left. So 11 days into the promotion, I give away all the samples. It takes 11 days during the promotion until none of the samples are remaining. That's what it means. Now this says to see 1,210 customers. Now here's the catch. Customers are not free coffee samples. How am I to know if they give some people 2 coffee samples? They might give away 2 coffee samples to one guy. I don't know. This is not the same as customers. And you might have gotten this wrong because you thought, oh, it takes 11 days, right? X days to see that many customers. But this is not customers, it's coffee samples, right? This is free coffee samples. Customers and coffee samples are not the same. And if you're giving things away for free, are those even customers? I don't know. I'm not sure. So you may have put B, but if you put B, I want you to be a little bit more cautious and careful about language. This, customers are never mentioned. I could give 5 coffee samples to one person, and then suddenly that's not 12:10, it's 12:05, 12:06. There are 11 samples available at the start of the promotion. No, there are 12,000. And remember, my way of kind of unpacking this is as I kind of read through the question to try to really wrap my brain around it, I plug in 0 and 1. That's my strategy. Do you have to plug in 0 and 1? No, you don't. Could you have like maybe moved through this faster and then just figured it out? Maybe. But if you're watching this video, my guess is that you had a little bit of trouble wrapping your head around this. And if so, this is a good strategy to help you get into that mindset. You don't have to do it, but you have enough time in this test to do it and still get it right. So it's up to you how you approach it. But that's one way to approach it, and then C is the answer. Cool? Number 12. Which scatter plot shows a negative association that is not linear? And then it says, note, a negative association between two variables is one in which the higher values of one variable correspond to the lower values of the other variable, and vice versa. So that would mean the higher values of this correspond to the lower values of this. So we're going like high here, low here, right? Oh yeah, like this. That actually works. And then we have the lower values of y correspond to the higher values of x. So when x is high, y is low. Oh yeah, this totally works. That just seems like a downward trend. Now this is another downward trend, right? This is another downward trend. So both of these are downward trend, but this one looks pretty linear and this one curves a little bit, okay? Now this looks like a parabola, but here's the problem. Sure, this is high and this is low, but over here, x is high and y is high. And as I go this way, x is going to be really high and y is going to be really high. So this doesn't exactly correlate, okay? That doesn't exactly work. Down here, this is what I call like no meaningful relationship. They're all over the place. There's like, how do I draw a line of best fit? I don't even know. That's just lines, dots everywhere. So there's no meaningful relationship there. So a negative association, it's got to be A or B, and now we're just looking for one that is not linear, and that gives us B, because it's curved. It's that simple. It shouldn't be that hard, but I realize that these can kind of be a little bit crazy for you guys. This is scatter plots. Scatter plots. You might also check out key features of graphs. They tend to be related problems that deal with very similar ideas. Key features of graphs also might come into play. And a lot of times you'll have multi-step problems that are scatter plots and key features of graphs problems. So those are two places to kind of look for similar problems. The histogram above shows the distribution of heights in meters of 26 pyramids in Egypt. Cool. Which of the following could be the median height of the 26 pyramids? So whenever I have a number of items and I'm looking for median, I can use a shortcut, and that shortcut is counting in. Okay, I'm going to show you how to do this. This is center, spread, and shape of distribution. So this is center, spread, and shape of distributions. And it is also averages, which we're going to do an in-depth video on averages eventually. It may not be out yet, depending on when you watch this video. But this is averages, which is mean, median, mode, and standard deviation. Okay, so we're going to count in, again, this is my medians shortcut. And the way that we count in is the frequency tells us the number of pyramids. So this is like 2 pyramids here, right? 2 is like 2 pyramids. So I'm going to count in, if I have 26 pyramids, I want the split between 13 and 13, right? So I want to count in 13. So this is 2, this is 4, this is 12. Oh, if I count in 13, 13 is going to be somewhere in here, right? My 13th in, because this is 16, 17, 18. This is 18. So my 13th and my 14th, right? I want the split of my 13th and my 14th. They're going to be somewhere on here because this is 18 in total, right? Pyramids. So I know it's got to be between 45 and 60. And only one of these numbers is between 45 and 60, and that's the answer choice B. So that's how I figured this out. I know that this, like each little box that I draw here like this, represents one pyramid. So I know that this is like 1 pyramid, 2 pyramid, 3 pyramid, 4 pyramid, 5 pyramid, right? Oh, I guess that's not 4, that's 3. It doesn't really change the end game number though. Oops, I totally did that wrong. You guys are like, Brooke, you made an error. I did make an error, but luckily it's not an error that will cost me anything. 5 plus this is still 17, even if it's not 18. My quick math. This is what happens when I try to explain at the same time. 12 plus 5 is 17. So still we're between the 13th and 14th. We're still on this big bar. I really don't have to worry about the accuracy here because it's like so obvious that this is going to be the next one. If you wanted to, you can even draw out all these boxes. You can do 5, 6, 7, 8, 9, 10, 11, 12. There's my 13th. Oh, look, it's right there. 13th, and then my 14th is here. So then my median is going to be somewhere in here. But the thing is like, I have no idea from this bar chart, or this histogram, I have no idea if this is all 46, 46, 46, 46, 46. I have no idea. All of these 12 items could all be the same number. They could all be 48 meters. I have no idea. I just know there's something in between those. So B is our answer, and that's it. Cool. 14 to 16 refer to the following information. So this is table data. We might get into some other ideas as well here, but if you want more practice problems that are similar to this, you should go mosey over to table data. We have a download worksheet of table data. You can go work on this skill and do some more of those. A survey of 170 randomly selected teenagers aged 14 to 17 in the U.S. was conducted to gather data on summer employment of teenagers. The data are shown in the table below. Biggest issue that people make when they do these problems is that they don't grab the right information. Which of the following is closest to the percent of those surveyed who had a summer job? Now this is also percents, by the way. And we have a skills video on percents. So if you want to review your percents, you can go to skills on percents. But that's not usually why people miss this. People miss this because they're not precise enough. Of those surveyed who had a summer job. So we have a summer job total of those surveyed. This is all the people surveyed. So what I want is I want my total number here and I want my number here. Mistakes people make. They look at have a summer job, they just go to the 20 and they look at total over here and they didn't realize that this is just ages 14 to 15. It's not the total. So I want of those surveyed, I have to make sure I have the right numbers. Okay? So it's just going to be 59 over 170. And 59 divided by 170 is 0.347, or 35%. And this says is closest to. The other thing that I do, whenever I round on this test, I go back to the question and I look for language that says it's okay to round. If I ever round, I always look for rounding safe language. FYI, cool? Because if I don't find language that says it's okay to round, I probably made a careless error. And then I can go correct it. It's like a gift from the College Board to me and to you. 2012, population of the individuals in the United States who were between 14 and 17 years old was about 17 million. Whoa. If the survey results are used to estimate information about summer employment of teenagers across the country, which of the following is the best estimate of the total number of individuals between 16 and 17 years old in the U.S. who had a summer job? Okay, lots of stuff here, so let's just break this down a little at a time. In the 2012, the population of individuals who were between 14 and 17-year-olds was 17 million. So there's 17 million 14 to 17-year-olds. Okay? The surveys are used to estimate information about the employment of teachers across the country. So what we're saying is this survey is a sample, and we're going to extrapolate that sample in order to understand broader, greater things. We're getting into data collection and conclusions here, okay? So I do cover how to do problems like this in our skills video that's on data collection, conclusions, and inferences. So this is a skills video that we have, okay? And in this video, I'm going to cover all of the terminology and like the stuff about samples and like all that crazy stuff. So we do cover some of this stuff calculation-wise. Data collection and conclusions, you might find some problems that are kind of similar to this, but you're also going to find some just in straight up table data because table data is also going to have these. So we have table data now, and we're adding in also this idea of data collection and conclusions and inferences. One of the things that drives me crazy about the SAT is that a lot of these problems technically kind of overlap in skill sets, and then the College Board throws them in certain categories, and those categories are not necessarily as organized as they could be, in my opinion, but whatever. That's why I'm here telling you and listing off all of these things that you can go look at if you need more help with something similar. Okay, if the survey results are used to estimate, so I'm going to use the survey results to estimate. So this is the total population. I want to estimate the total number of individuals between 16 and 17 who had a summer job in 2012. So this is a little bit tricky. We want 16 and 17 who have a summer job in 2012. So what I'm going to do is I'm going to say, if this is 39 and my total population is 170, and this is the ratio I have of has a summer job and is 16 to 17, right? Now here's the catch. This is a little bit dicey because we surveyed 89 kids who are 14 to 15, but it does say that these are randomly selected teenagers aged 14 to 17. So it was randomized. So this might indicate that there's actually more 14 to 15-year-olds in the world than there are 16 to 17-year-olds. So because they were randomly selected up here, and this is the kind of language that I'm going to go over in our skills video for data collection and conclusions and inferences. I'm going to go through all of this stuff and what it implies. I want the random selection to be from 14 to 17-year-olds, right? It needs to be randomly selected in order for this to transfer. And so it's randomly selected. So I'm going to assume that the ratio of 39 to 170 is an approximation of the ratio of this category to the whole population, okay? So I'm going to do 39 over 170 equals X over 17 million, okay? So this I just divide by 10 to get to 17 million. So this I'm going to divide by 10 and I get 3.9 million. Well, what does 3.9 million look like? Well, it looks like that. Cool. So I've got to deal with like 17 million versus writing out a million. And if that's why you got this wrong, if you put D instead of B because you didn't know what a million looked like, you should learn that this is 100,000 and that million is outside of that. You should probably learn that. Hopefully you know that. But there you go. Straight up. If you put 8.2 million, chances are maybe you looked at the total number of 16 to 17-year-olds. You may also have taken this out of the total number of 16 to 17-year-olds, but this says this is between 14 and 17, not 16 to 17. So if you thought this said 16 to 17 and you didn't realize this was a 14, then, you know, there you go. Could be a problem. That could also potentially get you that 8.2 million because you didn't have the bottom number right. And that's the most common mistake that I see people make. They don't have the bottom number right. Obviously, this is a decimal point in the wrong place. And then 2 million, I don't know where 2 million comes from because that, maybe that's the 14 to 15. Maybe you took the 20. Maybe that's the 2 million. So you took the 14 to 15 instead of the 16 to 17-year-olds. Cool. So it's just picking out the wrong data. So that's table data. I go over some of those skills in table data, but you're also going to find it in data collection, conclusions, and inferences skills video when I talk about extrapolating sample size to bigger size. We have to make sure we have the same ratio comparisons and we're choosing the things that are relevant to each other. Okay? Cool. So that was 15, and the answer was B. Ta-da. Okay, based on the data, how many times more likely is it for a 14-year-old or a 15-year-old to not have a summer job than for a 16-year-old or 17-year-old to not have a summer job? So this is kind of a crazy question. It's kind of confusing. You might be like, I don't know how to calculate how many times as likely is it. So first, let's calculate the probability that a 14-year-old or 15-year-old does not have a summer job, okay? So the probability that they do not have a summer job, remember probability is just a number between 0 and 1, and this, by the way, is probability, which we'll have a skills video eventually for probability. But for right now, where are you going to find probability? You're going to find it table data. I think this is going to be in table data. So we're going to have a skills video eventually for probability, but in the meantime, you can check out table data for more probability problems, but there's going to be problems that aren't probability in there. Kind of annoying. In any case, let's talk about probability. Probability is always a number between 0 and 1 that takes the number of options that give you what you want over the total number of options. Okay? So the options that give me what I want are 69, right? And my total for a 14 to not have a summer job, the probability that a 14 or 15-year-old does not have a summer job is 69 out of 89. Now again, I have to get my top number right and my bottom number right. The top is 69 because that's the number of 14 to 15-year-olds that don't have a summer job. The total number of 14 to 15-year-olds, if I know that that's their age category, is 89. So this is my probability for that. And I want to know how many times more likely is this. So this equals how many times this, a 16-year-old, 17-year-old to not have a job. So the probability they don't have a summer job is 42 out of 81. So I'm going to solve for those two elements first, okay? So let's get out our calculators. This is one where you really want a calculator. Get out your calculator, people. I'm just going to use this little bitsy calculator. 42. Remember, you can't use your cell phone on the test, so don't bring your Apple device thinking you can use it. You can't. So this equals 0.518 something, blah, blah, blah. Let's see what this equals. 69 divided by 89 is 0.77528. So I want to know, how many times more likely is it for a 14 to 15-year-old to not have a job? Is it more likely? Yeah. They are more likely than these folks to not have a job. So I want to know 0.77528 equals 0.51 times x, which gives me how many times more likely is this than this? This is x times more likely, right? If I take the probability of this, I multiply it by x, that gives me how many times more likely is this than that, right? So it's going to be some number over 1. I know that to start off. Now I'm going to divide. So I'm going to take my 0.775 ugly thing. I'm going to divide it by 0.518. I think it's 0.5185. And I get 1.495. Well, that rounds to the nearest tenth to 1.5. So I'm going to put 1.5 times as likely. And I'm done. Cool. Why you could get this wrong? You could get this wrong because you mix up the order down here. You could think it was asking how many more times likely is it for a 16 or 17-year-old to not have a summer job than a 14 or 15-year-old. And then you're dividing the other way, and then maybe you could get A or B. And I don't know where this 1.64 comes from, but maybe it comes from mixing up numbers. Or maybe it's having a summer job, if you calculated the probability of having a summer job versus not having a summer job. Maybe you calculated the wrong one. In any case, hopefully you guys understand this. The first thing that I do is I find the probability of each event, and then I say the probability of one is something times the probability of the other. And I make it pretty simple. I think most of the time when you guys miss this, you don't even know where to start. So hopefully that explains to you where to start. Start by finding the two probabilities, then figure out one probability is the other probability times something. That simple. Okay, a little bit confusing, but not too hard to solve if you know what to do. All right, let's pick up here with number 17, percent protein in 5 food products. And then we have percent protein in food products. The graph above shows the amount of protein supplied by 5 different food products, and there they are, as a percentage of their total weights. The costs of 10 grams of products A, B, C, D, and E are, so these are the costs of 10 grams. Which of the 5 food products supplies the most protein per dollar? So this is a little bit confusing. I'm first just going to write these on top of here just so I can kind of visualize this. $2.50, $4, and this is $5. And so what we're saying is that this is like 10, this is how much I pay for 10 grams, right? Total. Now the other thing that I know is this is a percent of the total, right? So what I actually want to figure out is if I purchase 10 grams of all of these, how much protein would I get, right? And then that would be the cost for that protein. So what I essentially want to know is protein per dollar. Okay, protein per means divide, guys. So if you didn't know that, it's a really good tip. Protein per dollar is what I want, okay? So how do I get protein per dollar? Well, I'm going to have to know how many dollars I paid, and then I need to know how much protein there was. So how do I figure out how much protein is in all of these 10-gram samples that I bought? Well, I'm going to take my total, right, times my percent of the part, and that's going to get me my numeric amount of protein. Okay, because right now I don't have a numeric amount of protein. I have a percent of protein. So I can't just put these percents over the dollars. That's not going to work. I have to figure out how many grams of protein I have over the dollars because I want the most amount of protein, not the most percent of protein. Just because it has a bigger percent, I guess the percent is kind of the same because if it's 10% of 10 grams, right, and 15% of 10 grams, if these are all the same sample size, then I guess it's kind of the same. But just to be safe, I'm going to calculate out the exact protein amount. And that's just to be super safe. Do I have to do that? Maybe not, but it's going to take me longer to think through and be 100% sure that I don't need to do that than it will for me just to go ahead and do this as a part of the 10 grams. So 10% of 10 grams is going to be 1 gram, right? 15% of 10 grams is going to be 1.5 grams. And how do I do this so fast? If you can't do this so fast, remember this is the calculator section. So get out your calculator and you can do 10 times 10%, okay? And you could do that and you would get 1 gram. All right. I could also set this up if this is confusing to you and you don't quite understand how this works, right? If I have 10 grams of protein, that's my total. Another way I could do this is with a percent proportion. So if you like that better, you could do it that way too. If I have 10 grams, I have part over whole, and the part is what I want to solve for, right? I want to know the part, the numeric amount of protein, that part that's protein out of the total equals 10 over 100. So I could also do something like this and then say 10 times 10 is 100, and what times 10 is 10? 1, right? So that would be 1. So you could also do this with a percent proportion. You can also do it with the basic percent equation, which is you take the total, you multiply the percent of the part, and you get the numeric amount of the part, right? That's also here. So places to look if you need more help with this, we have our percents video and packet, and this is actually in our skills section. So the other place you can look is a chapter called ratios. I just call them chapters, but rates in units, because they're downloads and they're videos that we have, or problem sets at least, and videos, depending on which iteration of the course you're watching. So we have ratios, rates in units, and we have percents. Those are the 2 places that I would go look. And these are going to be both skills videos. These basically builds on skills. Now, this is also in content. If you want to do content, you're looking at units. Percents doesn't have a content. So units, and then I think like ratios. Those are the 2 words to look for if you want to look in the content videos. But these are the 2 videos that are going to be the most helpful for you guys. Cool, let's get back to work. So here we go. I'm just doing this, right? And I'm going through these and I'm calculating each of these percents. So this is going to be what? 20% of that is going to be 2 grams. Again, you can do this in your calculator. Remember, you do this divided by 100 times that. 25% is going to be 2.5 grams. And 30% is going to be 3 grams. So I'm just doing this because I want to have it be totally precise. So I have 1 over $2, right? This is going to be 1 over $2. This is going to be 1.5 over 220. This is going to be 2 over 250. And then E is going to be 3 over $5. I'm going to go through these really fast, and now I'm just going to get out my calculator because that's the best way to do these. This is actually 1/2. That's easy to see. 1.5 divided by 2.2, we get 0.68, so that's a little bigger. I want the most protein per dollar, so I want the protein to be bigger. So that's going to be out. I'm going to skip down here. What's 3/5? 3 divided by 5 is 0.6. Now we have 2 divided by 2.5. 0.8. Okay, so that's definitely the highest of these 4. If I really want to be thorough, I could also do D, which is not an answer choice, but just making sure that D isn't giving me a higher answer to make sure that I didn't do some screwy math. 0.625. So the other one is 0.625 if you wanted to know what D was, which is not an answer choice. So if you want to be really thorough, you could do that too. You don't have to do that though. Generally, you just have to check the ones that are here. And obviously C is going to be our biggest amount of protein per dollar. And so answer choice C is correct, okay? Again, did I need to actually figure out all the grams? If I did 20, you know, what if I used the percents? Would it have given me the same thing? I don't know. That's why I always play it safe. You never know when little shortcuts can get you into trouble, but we could try that really fast. 10% divided by 2 is 5. And then we have 20% divided by 2 is 10. Yeah, so that's double. 6.8. Yeah, I mean, I think that's going to work too. Had you done it that way, I think it works too. 5 divided by, what is it? 5, 6, yeah. So anyhow, if you had done this without actually finding these grams because you realized that, oh, I'm just multiplying all of these times the same amount, it would have worked too. So I could have also, with this protein over dollars, I could have used the percents and I still would have gotten the right answer. So those of you that like wanted to do it that way, I still would have gotten the right answer. Had these numbers been different, had there been different amounts of grams in each package, that would not have worked at all. I always like to play it super safe. I find that I don't run out of time on this test, so I don't need to take shortcuts like that. If you find yourself running out of time and you want to take a shortcut like that, You know, what I would say is maybe you can take that shortcut on the front end, and then if you have time, come back and just like always be 100% certain. I always like to do things the safe way. Obviously, if you can see that relationship and know super confidently that like, oh, it's going to be okay if I just use the percents too, that's cool. But there you go. There's a couple different ways to solve it. You could have just taken the percent of the protein also and divided it by dollars. You still would have gotten answer choice C. In any case, there you go. That's how you solve it, and that's what this is, and we can kind of solve all that down one piece at a time. Cool? In quadrilateral ABCD above, BC is parallel to AD, so I just marked that, and AB equals CD. So that means those two are equal. That means their base angles are equal because it's an isosceles trapezoid. BC and AD were each doubled, so I'm going to now label these as B1 and B2. And so then I'm going to double them, and I'm going to create some trapezoid that's like, and this is just obviously not to scale. So this is B1 doubled, and then this is B2 doubled. And BE was reduced by 50%. I'm going to label that H, and then I'm going to label this 1/2 H, okay? How would the area of ABCD change? So what I'm going to do first is I'm going to find the area of each of these in terms of B1, B2, and H. All of you should know that the area of a trapezoid is 1/2 the sum of the bases times the height. So basically, if I found the average of the bases times the height, that's going to give me my area. If you want to kind of know why that's true, you can see how what I can do is I can take this triangle down here and like move it up here. You guys see how that works? And then I can do the same kind of thing over here. So if I go through like where that midpoint would be, I can move this over here, and then I move that over there. So instead of finding those things, do you see how I've just created like this rectangle here? And then I just find the area of this. What's the rectangle area? It's height times this line here, which is that midline, that average of those two bases, okay? So that's where the area of a trapezoid comes from, if you were wondering, or if you're a little bit rusty on geometry. This is a geometry question. By the way, these geometry questions are pretty rare. They don't happen that often. This is similar shapes, so if you want more practice on this in our content section, go check out similar shapes. There's a whole problem set of those that you guys can go take. So getting back to this, this is how we deal with this. I'm just going to find the area of this, and how do I find the area of that? I do 1/2 B1 plus B2 times H, okay? And now I'm going to do the same thing over here, but instead of using B1 and B2, I'm going to use 2B1, 2B2, and 1/2 of the H, right? So this is 1/2 of 2B1 plus 2B2 times 1/2 H. So now I'm just going to use algebra and manipulations and just simplify this out, right? I'm going to do 1/2 times this, 1/2 times this, and that gives me B1 plus B2. Oh, look, when I distribute that out, what happens? It like totally goes away. Now I never distribute across multiplication. Do you see how this is added and then this is multiplied? When you distribute, you don't distribute across multiple things that are multiplied. You just distribute across the thing that's right next to it, and that's it. So now I get this times 1/2 H. Check this out, guys. Do you see how this and this are actually identical? So if I double this and I double this and I half this, guess what? My new crazy trapezoid that's going to be really like long and skinny, right? Like this, something like this, right? Is going to have the same area as this trapezoid. So the area would not change. And that's it. It's that simple, but you just use that algebra knowing the area of a trapezoid. If you guys don't know the area of a trapezoid, you should know that there's a handy dandy little thing over here, but as you can see, trapezoids aren't here, so that makes it a little bit harder. You do have rectangle and you have triangles, so you might be able to kind of like cut stuff up or estimate stuff, but the best thing to do is just to know these and have them memorized. Unfortunately, that's not a formula that's up there. It's always good to know that that's where your formulas are. In case you don't know something, you can look there and see if it's there. But obviously, this formula is not there. And here we're in a situation where knowing that formula is going to be a lot easier. And I'm not going to show you how to do it without that formula because I think that is the best way to do it. You just need to learn that formula of a trapezoid area. The average of the bases times the height. There you go. Okay, cool. The other thing is some of you might have asked, how did you know reduced by 50% meant 1/2? Well, if I have 100% of something, right, and I reduce it by 50% of something, right, guess what that leaves me with? It leaves me with 50% of something. And remember, 50% is 1/2. So if you were looking at that and didn't understand that, you could always set up an equation like this if you're confused or you want to double check. But there's that if that was confusing. Hopefully we're all good. And finally, if this were really tough for you, you could always make up numbers and then actually solve it out. So you can make up numbers that are easy. Like I could make this like 3, and I can make this like a 3, 4, 5 triangle. And I can make this 3, and then I could just arbitrarily make this 6, right? So I could just arbitrarily make up numbers and use triangles and stuff and then solve it out and then double it. So that's like the last ditch effort. If you really didn't know that formula, that could be a way that you solve it. Okay, cool. 19. Boyd grows only tomatoes and raspberries in his garden. Last year, he grew 140 pounds of tomatoes and 60 pounds of raspberries. This year, the production by weight of tomatoes declined by 20%, and the production by weight of raspberries declined by 50%. By what percentage did the total yield by weight of Boyd's garden decline? So we know this is a percents problem. This is definitely in percents. We already have that skills video up and ready, so you guys can go check it out. It's pretty in-depth. So go check out percent skills if you missed this. You definitely want to practice those. We've got a good practice set with that too. Go check it out. Boyd grows only tomatoes and raspberries. Last year he grew 140 pounds of tomatoes. So I'm going to write this down. And I usually write this down on my first read, but that's okay. I was just kind of seeing the lay of the land. And then 60 pounds of raspberries. This year by weight, the tomatoes declined by 20%. So the first thing I'm going to do is say, how do I calculate how much tomato stuff I have this year? Well, if I have 140%, and that has declined by 20%. Whenever I have a reduction in percent, what that means, there's two ways I can think of it. I can either think of it as 140 and then minus 20% of 140. That would create a 20% decline, right? But the shortcut for this would be to think, if I'm getting rid of 20%, I'm keeping 80%, right? So I could also do this in a single step by just writing 80 over 100 times 140. And remember, you can also write this as the decimal. If you like decimals better, that's always an option. It's totally cool. If you're a decimal person, awesome, great. If you're a fraction person, that's fine too. Whatever's easiest for you. So you can see there's like all these kind of different ways. This way it tends to be the way that the test prefers when you get into percent problems that are actually like have variables in the answer choices or more about like equation setup and stuff like that, because they're going to ask these questions. Sometimes they want a numeric answer, but other times the test wants you to do things and set them up with variables. And in that case, this is much more in line with what the SAT would do usually, but you never know. It's always good to know all of them. So we have 140 pounds of tomatoes. So we're going to reduce that by 20%. And I'm just going to calculate this out really fast. I'm going to do 140 times 0.8. And again, however you set it up, any of these are going to work. And that gives us 112 tomatoes this year. Okay. So I'm just going to put TY for this year, and I'm going to make a little chart. So that's 112. This year, by weight, it declined, and by weight, the raspberries declined by 50%. Now, 50% decline is really easy. That means we have half of what we had. If you want me to set it up like this, I can do it that way too. I can do this minus 50% of 60. And what's 50% of 60? That's 30, right? It's 1/2 of 30, or 1/2 of 60, which is 30. So 60 minus 30 is 30. This I can actually do in my head. I don't have to like do this, but if you guys want to see it, it's there. By what percentage did the total yield by weight of Boyd's garden decrease? So his total yield by weight means that I'm going to figure out the percent decrease is always new minus old over old. And I have these written down over here, or it's numeric change over original. These are the two ways to calculate percent change. Percent change can be percent decrease or percent increase. And these are really important, just very, very simple formulas to memorize. They're not that confusing, new minus old over old, or numeric change over original. So what I want is the numeric change over my original. I know this year, I'm going to add up this year, and I get 142 pounds, right? And now I'm going to add up these. 140 plus 60 is 200 pounds, right? I'm just going to make some space here. That's 200 pounds. So I know that this is my original, right? And this is my new. And it said, did Boyd's garden decline? So I'm looking for that decline. So it's definitely in that order. With percent problems, sometimes it's really important to keep aware of how it's worded. Occasionally, they'll throw you a loop with the wording, and you have to calculate something that you don't usually calculate. So this is our new, and this is our old, right? So I'm just going to do this new minus old over old. 142 minus 200 over 200. Most important thing, the biggest mistake people make, is that this is not the number on the bottom, okay? So make sure that's your bottom number. Make sure your old is on the bottom. Do not put the new one on the bottom, okay? And we always go from something to something else. So whatever we're going from to, the from is our original, okay? So you gotta, that's when I say you have to be careful of the wording. You have to see what we're going from and what we're going to. So now I just figure out what's my numeric change. Now you can see this is going to be negative. That's what happens when we have decrease. Whenever we have a percent decrease, you should get a negative number, which is negative 58. And then we're just going to divide that by 200. And we get 0.29, so it's 29% decrease. So it's negative 0.29. And remember, that's 29%. Remember this, we could just move over to get to 29%, okay? Cool, and it's 29%. If you put this over 142, guess what you would get? I'll tell you, this is wrong, by the way. This is not how you do the problem. 58 divided by... If you got 41%, which is not on here, if you got 41%, which is totally wrong, you divided by the wrong old, okay? So don't be that person. Hopefully you can get this one right. Okay, cool. Really basic percent growth, percent change, percent decrease kind of problem. We have lots more of those in our percents, and I have a whole video on how to set up percents, so you can go check that out. Awesome. 20. All right, we have this fun histogram bar graph thing here. The graph above shows the frequency distribution of a list of randomly generated integers between 0 and 10. So this is how often the frequency of randomly generated numbers. What is the mean of the list of numbers? So whenever we need a mean is just a fancy word for average, okay? And what we have to do sometimes is convert our histograms or convert our graphs to actual data sets, okay? What this means is that I got 0 once. So in my list of all the numbers I ever got, I got 0 once, 1 once, 2 once, 3, 1, 2, 3 times. So that means it's 3, 3, 3, right? Then I got 4 twice. I didn't get 5 ever. I got 6, I got 7, I got 8, I never got 9, and I got 10, okay? So this is what I want to find the average of. Got it? And so now you just get out your calculator, you add all those up, and you divide. I could have also done this by finding like the individual sums of all these. So this is like 0, 1, 2. This is going to be 3 times 3, which is 9. This is 4 times 2, which is 8. So I also could have done it like this, and sometimes I write it out like this. But either way is fine, 6, 7, 8, and 10. You see how I can take this number and then multiply it by this number, and then I can also add that together. The only thing is I have to be sure that I know how many pieces are in my data set. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oftentimes, it will tell me how many numbers are in the set. Down here, it doesn't do that in this case, so I really need to know how many there are. So I think listing them out is probably the way that I would do it here. In any case, there's a little commentary. All right, so I'm going to divide by 12 when I get the sum. And we're going to do 0, that's obvious. 1, 2, so these together are 3. And then 3 more 3s, that's 9, that's 12. So I'm going to just start with 12. Obviously, you can add these all up one at a time if you want. I'm going to do plus 8, plus that 6, plus 7, plus 8, plus 10. Okay, so I get 51. I'm dividing that by 12. I get 4.25. So then I look for that. Yeah, this should be exact, by the way. If for some reason you got something not exact, you probably made a mistake. That could mean you forgot a number. That could mean you counted the number of numbers wrong. If you ever get something that's not exact and it doesn't say we rounded, be super cautious. Be super careful. You probably made a small error. Okay? Mean, though, not so bad. Mean, median, and mode, those are all in averages. We're going to have a skills video on averages. If it's not out yet, it will be out at some point. So you can earmark that. The other thing that you can check out, table data. A lot of average problems show up in table data. So that's the other place that you can go practice. If you want to practice mean, table data is where you're going to have a lot of mean problems. So averages when it comes out, and for now you've got table data if you need to do more stuff that's kind of similar to this. Okay? Okay, number 21. What is the minimum value of the function graphed in the xy plane above for x's between -4 and 6? So the first thing that I want to tell you guys is we only care about values that are graphed here, because I only care about the domain from -4 to 6. And I do care about the exact points that this includes, right? But I want the minimum value of the function. Quick tip, minimum value of a function is always the f of x or the y value, okay? Whenever I say a minimum value or a maximum value of a function, I always mean the y value. I don't mean the x value. And I think that's the most confusing thing for people when they hear minimum or maximum of a graph. They don't know what that means, or they don't know what to look at. So our minimum value is always a y value, and it's the lowest y value possible. So here that's just -2, okay? Now here's some things that people put and why they put them. Some people put -4. Now this is the x value that creates the minimum value of the function. Remember, of the function is like of f of x, right? We could replace this with f of x. So what's f of x? F of x is a fancy way to say y. So remember, this is the x that creates the minimum, right? The minimum is at x. At what x value is the minimum? I could ask that. If it said at what x value is the minimum, it would be b, okay? What is the minimum value of the function overall? Would be a, right? So this ignores the domain that they give you. When they give you that domain, it's constricting. That's the only place we care about. And 1, I don't know why someone would put 1. Why would you put 1? 1 is right here, right here. I don't know why that's there. So I have no idea why you would put 1. I understand why you would put B. I understand why you might put A if you're not paying too much attention. But our answer here is C. Okay, so just remember minimum value is always f of x equals y. Where can you go to get more awesome graph stuff? So this is probably nonlinear equation graphs. A little bit of this also might be in functions, because this does say of the function. So function notation, sometimes when we have charts of functions and things like that, and we talk about what does minimum value mean, minimum value always means the y value. That's also like a content thing that you'll find in functions and function notation. But nonlinear equation graphs is what this is. If you want to do more of these, we have those in our content problem sets. You can go practice some more. Okay, number 22, scatter plots. Okay, so this is a scatter plot. I can look at it and know it's a scatter plot. So there you go, scatter plots. So if you want more of these, go to scatter plots. Though there might be some other overlying issues here. In 1929, Edward Hubble published the data shown the graph plots the velocity of galaxies relative to Earth against the distance of the galaxies from the Earth. So we have velocity over here, distance over here. Hubble's data can be modeled by this equation, so we have an equation modeling it. So if the equation models it, guess what that's probably? That's probably the line of best fit, right? So whenever we have equation modeling data, that's like our line of best fit for a scatter plot. Got it? Okay, according to Hubble's data, how fast in meters per second is galaxy Q moving away from Earth? So I want to know meters per second. Okay, so I'm going to write this down. Whenever you have something underlined, you better pay attention, because that means we probably have to do a unit conversion. So this is probably units in addition to scatter plots. Meters per second. Okay, so is galaxy Q moving away from Earth? So here's galaxy Q, and we know that its distance is 2.0 mpc. So we have 2.0 mpc. And then we have velocity is kilometers per second. Kilometers per second. We have 500 kilometers per second, and they want to know in meters per second how fast is Q. So I'm pretty sure all we have to do is convert 500 kilometers per second to meters per second, because I'm guessing that velocity is the speed at which we're going apart from Earth. The velocity in kilometers per second at which the galaxy is moving away from Earth. If you want to double check it, you just need to go back and read and see what it says and confirm that moving away from Earth and moving away from Earth match what v is. Do you see how I do that? So if you really want to be certain, you can do that. And all I have to do is convert this. So my question is, how many meters are in a kilometer? Well, let's think. I like to think of grams. When I have 1 gram, right, I can also have 100 grams, or I can have like 1 kilogram, right, which is like 1,000 grams. So a kilo means 1,000, if you don't remember it. I don't know. I know as Americans, like we're like clueless and we never use kilometers or meters. And that's why this might be hard for some of you guys, because you literally don't know that kilometers is 1,000 meters. But kilo means 1,000. I, for some reason, have an easier time remembering with grams, and maybe that's because I just think of all the packaging that has like the European grams listed on it. And this is like a package of candy. This is like a single tiny runt or something. This is like a package of candies. And a kilogram is like a good amount. It's like 1,000 of these. It's not 100 grams. 100 grams, it's like a little packet of candy or something. It's like 100 grams, okay? So that's kind of how I remember that kilo means 1,000. Whatever floats your boat and helps you remember kilo means 1,000. So we're gonna do this like this. I'm gonna do 500 kilometers. Whenever I have per second, I like to rewrite it like this. So I separate out the kilometers and seconds. It just makes it easier for me with my dimensional analysis mind. Next thing I wanna do is I want the kilometers to cancel, and I want it to turn into meters. So then I have to think about how many meters are in a kilometer. Well, 1,000 meters are in a kilometer. Oh, another way you could think of it too, if you run track, right? The 100-meter dash is like really short, right? But a kilometer is like, oh my goodness, that's what a car drives. So it's not going to be 100 meters, it's going to be 1,000 meters. So maybe that's another way you could remember it. Anyhow, back to work. 500 kilometers over 1 second times 1,000 meters over 1 kilometer. This is just dimensional analysis. We go over this hardcore in ratios, rates, and units chapter / video. If it's not up, it will be up soon. So keep your eyes peeled. So here we go. We have 500 kilometers per 1 second, and then we're going to multiply that by 1,000. And all I have to do is add zeros, by the way. So if I have 1, 2, 3 zeros, and I have 1, 2 zeros, I just add all those zeros together, 1, 2, and I want 5 in total. Oops, I guess I put that in the wrong place. It should be 500,000. Miscounted there. So that's 500,000 meters per second. And now we have to turn this into scientific notation. Okay, so we have 500,000, and I'm going to go 1, 2, 3, 4, 5. So it's 5.0 times 10 to the 5th meters per second. There it is. Ta-da! Okay, easy enough. That's it. I just have to pull this from up here and then convert it. So that's units and a little bit of scatterplots. That's it. Pretty simple if you know what you're doing. And again, I think the hardest part is remembering that kilo is 1,000. If you know that, you're probably in good shape. If you want to know more about dimensional analysis, units is the content, and I go over it in units, and that's straight up where you need the practice. So this is your practice set to go do. And then ratios, rates, and units, we're going to do a skills video. If we haven't yet, it will be out soon. So keep your eyes peeled for that. And you can do even more with dimensional analysis. 23, there are 4 galaxies shown in the graph at approximately 0.9 MPC from Earth. So the first thing I'm going to do is go look for those. I like to take these sometimes one little piece at a time. 0.9 MPC from Earth means it's like here. Boom, boom, boom. Oh, look, 1, 2, 3, 4. Found them. Which of the following is closest to the range of velocities of these 4 galaxies in kilometers per second? So I want range of velocities in kilometers per second. Good news, I don't have to convert these because kilometers per second, this is already in kilometers per second, so that's brilliant. And I want the range. Range is always the biggest minus the smallest. That's it. That's how simple this is. So this is around 0. It's a little less than 0. I don't know how much less. And then this is around, let's see. I mean, this is 500. This is 1,000. So this is like 750, right? This is like 750. So maybe this is 650. I don't know. 650 minus 0. It's around 650, I think. Oops. So I'm looking right here for something around 650. And oops, I had it circled. I didn't mean to do that. But I'm looking for something around 650. I have 700. That's pretty close. I'll buy that because this is kind of a little bit below. So maybe what I can do is I can take the differential down here, like how this is like 1 like that, and then put this right here, and then kind of go across. And that doesn't seem like quite at 750, which is right dead between them, but it's pretty darn close. Like 700 sounds pretty good. So it's 700. Okay, and we know that 450 is too far away. All I'm doing is subtracting this from this. This is about 0. This is around 700, 650, something like that. I just take those two values and I subtract them. 600 minus 0 or 700 or whatever you estimate it to be. Something probably in that range. This is definitely too small though, 450, because 450 would say that we were below this line, which I know it's not below that line. 450 would say it's like smaller than that range, which it's not. So I know that can't be right. Again, that's just scatterplots. So you can find that in scatterplots if you need more of those. 24. Based on the model, what is the velocity in kilometers per second? Thank goodness that's the same as it was over here. Of a galaxy that is 15 MPC from Earth. So if I'm looking at 15 MPC from Earth, I only have to 2.5, right? So in order to estimate this, I'm going to use the function right here, right? Which is my line of best fit. So I'm actually just going to be plugging into this. So I have V equals 500D, right? So this is probably scatterplots also. This is also just like linear equation word problem. You might also find things like this in linear equation word problems. Here's my linear equation. If I know it's 15 MPC from Earth, I have to figure out what is the MPC, what is distance? Oh, D is the distance in megaparsecs of the galaxy from Earth. So that's the distance in megaparsecs from Earth, so that's the D. So I do 500 times 15, and that's going to give me my velocity in kilometers per second, right? And if you need to check that, you can see V is the velocity in kilometers per second. So this is all I do, 500 times 15. I'm going to use a calculator because why not? We can. 500 times 15, ta-da! 7,500. So I'm going to put 7,500, and we're done. It's that simple. And when we see based on the model, as soon as I see that this is off the chart, you guys see how this is off the chart? Woo, 15's like way over here, right? I can't even really extrapolate that just here. I've got to go way over here. So that's when I'm definitely using my line of best fit there. And they give me the line of best fit. Now, if they don't give you a line of best fit, sometimes you have to create your own. And how do you do that? You just grab a point and you grab a point, and then you can do slope-intercept form and calculate it out. So another handy thing to do, but we don't really need to do that here. That's it. Cool? Awesome. Okay, everybody, let's read number 25. Janice puts a fence around a rectangular garden. Let's draw a rectangle. The garden has a length that is 9 feet less than. So 9 feet less than, that's like a fishing pole is how I like to think of less than. 9 feet less than means -9, and you fish it over to the far end of your setup or your expression. And then 3 times its width is just 3W, right? And then we put a W over here for its width. So we have those two things. That's the first thing that people screw up. They screw this up because they make it 9 minus 3W instead of 3W minus 9, and that totally screws everything up. So that's the first place that I see mistakes. The second place that I see mistakes on this question is right here. What is the perimeter of Janice's fence if the area is this? People mix up the perimeter and area. Remember, perimeter is going to be the sum of all the sides. So if this is a rectangle, then all I have to do is add these 4 things together. The other mistake that people make is they solve for the W instead of the whole perimeter. They solve for the length instead of the whole perimeter, and then they get something that's not here at all. So the area of her garden is 5,670 feet. So the first thing I'm going to do is do W times 3W minus 9 equals 5,670. From this, I can solve for W. This is just a quadratic equation. So this is going to be 3W squared minus 9W, and then I can move this to the other side, minus 5,670 equals 0. At this point, because this is the calculator section, if I have a program on my calculator, which I personally do, that runs the quadratic equation, I'm going to get that out and just have it do all the work for me and solve this down. If you don't have that, you could manually do the quadratic equation. The other option that you have is you could divide everything by 3 to try to clear this out and simplify this down a little bit. And then 3 goes into 5 one time, into 26 8 times, and into 27 9 times. So this is 189.0. So this is minus 1890 equals 0. So you could also do this and then try to figure out, okay, what 2 things multiply together to be 1890 that are 3 apart, something like that. And then what I'm going to solve for, now I'm going to write down my perimeter in terms of W, is going to be 2W, which are those 2 sides, plus 2 times 3W minus 9, right? So 2 of these guys and 2 of those guys, and we add that all together. I'm going to simplify this down really fast. 6W minus 18. So this is 2W plus 6W minus 18. So what I need is 8W minus 18. So I'm going to solve for W, and then I'm going to plug W into this expression, and then I'm going to get one of these. So let's talk about this. The other way you can do this is you can use a graphing calculator to find the zeros. So that's what I'm going to do right now. And I'm just going to type in, we're just going to swap x for w. X squared minus 3x minus 1890 equals y. Okay. And you can see here, we have 2 zeros. 45 and negative 42. So I'm just going to factor this now that I know those. W plus 42 times W minus 49 is going to be what this turns into, and that's going to give me, 45. So again, the other way that you could do this is you could use a graphing calculator and trace. 45, sorry, not 49. Or you could use a quadratic equation program in your calculator. We do have a program that does the quadratic equation, which you can download and stick on your calculator. We have videos that show you how to put programs on your calculator as well in our math videos section, the first tab that comes up when you click on math. You can go there and look for our calculator videos that will tell you how to put programs on your calculator. And if you go to the download section of the math, which is any download cloud above any math video, when you get into the math topic section, not down here in the question explanations, but in the math. If you click on that download cloud, we have a zip file that has several calculator programs. One of them is quadratic equations. So you could also have used that. But I just graphed it out and I figured out it was at negative 42 and 45. Remember, I flip the sign when I create the factors, and then I can see that these are the 2 factors, and this is going to give me a W of 45. This is going to give me a W of negative 42. Well, guess what? This is a rectangle. You can't have a width that's negative. So I instantly know it's got to be the 45 one. So that's just a clever trick. Whenever you're dealing with geometry and you have a quadratic that models something, you know it has to be the positive version. It can't be anything negative. So usually you're either going to get a double root, or you're only going to have one of the two choices that's positive. Or sometimes there's more than one possible, though I don't think that's what's going on here. Sometimes it says what is one possible, and then maybe you have to pick one or the other. So here W is 45, and now I can just plug in 45, right, into this, and then solve. So I get 8 times 45 minus 18, and I'm just going to do that in my calculator. 8 times 45, 360, and then minus 18 is 342. So 342 is correct. That's answer choice A. In terms of where these other things come from, I'm pretty sure the 300 feet comes from if you plugged in 42, if you messed up that kind of stuff. If we do this really fast, if I do 8 times 42, I get 336. Oh, that's where 318 comes from. So this is if you said W equals 42. And if you did that, you screwed up down here because you saw that negative 42 and you're like, I don't know, maybe that's 42. But it's not 42, it's negative 42. That's not positive 42. So don't mess up your signs on your polynomials and quadratics. So this is in our quadratics. If we don't have it up yet, quadratics and polynomials, we will be doing an in-depth video on these at some point. And I would recommend that. There's also nonlinear equations. Anything that says nonlinear equations, and this is stuff that we definitely have up no matter when you're looking at this video. But if we have nonlinear equation word problems, that's what this is. So technically this is a nonlinear equation word problem, but quadratics and polynomials is the skills that you need to know if you are making mistakes like this, where when you get like your answer choice and you get this and this, you mistakenly think, oh, this means the width is 42. And that actually means the width is negative 42, right? Because it means either this is 0 or this is 0. I can set both of these things equal to 0 and then come up with these two answers. And I know a length can't be negative, like that kind of stuff. Good to know. If you got 300 feet, I'm not totally sure how that comes into play. Maybe that's the perimeter. Oh no, we want the perimeter. Maybe that's the area. Oh no, this is the area. I don't know. I don't know where this comes from. I don't know where this comes from either. But maybe you guys do. In any case, probably some sort of careless error, probably some sort of strange something where you make a mistake. Maybe that comes from 9 minus 3W. Not sure. In any case, there you go. The answer is A. We're going to leave it at that. 26. Ooh, right triangle. This looks like some fun SupertutorTV. Indeed. So this is SupertutorTV. This stuff does not come up on the SAT very often. If you're missing things that are trig, study it last. Don't worry about this if you've got, you know, a 400 on this. This is not the first thing you should be studying. You should be studying algebra first. If you've got, say, a 650 and you're still missing this, maybe you should review your SupertutorTV because it's not that hard and you should be able to get this right. SupertutorTV is essentially the relationship that we have between side lengths, and this is how it works. So means opposite over hypotenuse, right? This is opposite over hypotenuse. Ka means adjacent over hypotenuse. And toa means opposite over adjacent. So what am I talking about when I say opposite over adjacent? What is all this Greek talk that I speak of? Well, when you have a right triangle, we can classify all of the sides in the following manner. The longest side is always the hypotenuse. It's always opposite 90 degrees. The opposite side versus an angle is always the one that's directly across from that angle. So this would be the opposite in this case here. And then the adjacent is the one that's sort of next door to the angle. So that's this side right here. So then sine, cosine, and tangent are all trigonometric values that follow the SupertutorTV pattern that we can use to figure this stuff out. Now, we will probably do an in-depth video at some point about SupertutorTV and stuff. I don't know if it's the first thing on our docket, but I do know that we already cover some of the SupertutorTV stuff in right triangle trig. That's the content that this overlaps with, okay? So if you go look for right triangle trig, there's a problem set. You can practice some more of these. It's good little practice. That's where SuperTutor is going to come up. Right triangle trigonometry. That's what this is. This is pretty simple stuff that you probably learned in 7th, 8th grade maybe. Maybe you just forgot it. Anyhow, let's go ahead and review how we do this particular problem. Given the right triangle ABC above, which of the following is equal to B over A? So B over A is going to be this over that. So if I'm at angle A, that could be adjacent over opposite for A. So what trigonometric value of A is adjacent over opposite? Well, I don't know that, but I know opposite over adjacent is tangent. Oh, wait, so what is this? This is cotangent, isn't it? Because it's 1 over tangent. That's the inverse of tangent. Now, from angle B, this would be the opposite over the adjacent, right? So I could also call this tan B, O over A, right? Because to B, this is the opposite. So while B is the adjacent to angle A, it's the opposite to angle B. So you see how opposite and adjacent, all these things, we read them according to what angle we're moving off of. So this is the tangent of B, and there's our answer, tan B, and it's that simple. So this is a super easy question if you know your SupertutorTV. And this is right triangle trig. We will probably do an in-depth skills video at some point going into more right triangle trig. Maybe we'll call it SupertutorTV even. But for now, in our content section, you can check out right triangle trig and just keep your eyes peeled. We might do more stuff on this eventually. More practice, more videos and things like that. But for right now, we've got our right triangle trig content video. We've got a problem set of right triangle trig. And you can go do those. More power to you. And get these right, because they're not too bad. 27. Okay, so here we have y is less than or equal to negative x. So here's what happens. Whenever we have inequalities in a plane, what's going on is each of these is kind of like a line, and then we shade above or below the line, because I can see that these two things are linear. So the first thing that I do whenever I have like linear inequalities is I get them in a slope-intercept form. So this is going to be y is less than or equal to negative x, and then this I'm just going to simplify out to y is greater than 3 over 2x plus 2 over 2, which is just 1, right? I'm just simplifying this out by dividing everything by 2. When I divide by 2, I don't have to flip the sign. Remember, I only flip the sign if I divide by a negative. And here, I know what value 2 equals, so it's easy to divide by it. So then I get these two things, and now I'm going to interpret for you guys what each of these means and how I graph them. This basically means I'm going to graph the line y equals negative x. What is this? This is the line that goes through the origin. I know because it has no b. It has a 0 where the b would be. So I know it goes through the origin. So right away, I know that's going to be the dark line, right? Just from that one little piece of information. I also know it has a negative slope that's at 45 degrees as long as your counting here and your counting here are evenly matched, right? It would have a 45-degree angle, so it's going to split this right down the middle. So I know that's this line right here, right? I know this is the line in question when it comes to this. Now I know y is underneath this line. That's what this means. Wherever this sign is, you think y is under this. That's the line. This is always the line, the blah, 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 blah. That's the line. So y is under the line. That means I'm going to shade down from this line. So I'm just going to draw a bunch of arrows because I'm going to shade down. Now when we come to this one, this means y is above this line. So this line obviously is the other line, duh, which is going to be this line. This line's going to go through 1. Yeah, it has an intercept of 1. It doesn't go through the origin. And then it's going to have a slope that maybe is not so... It's got a slope of 1.5, so it's going to go up. This should be steeper than this line. And graph are shown above. So I'm going to whine a little bit because from my viewpoint on this, these two look as if they have the same slope. I'm going to be honest, but one's negative and one's positive. And so it's not to scale. So don't expect it to be to scale, but at least I know that the steeper one has to be this one. And I know I'm shading up, so I'm shading up. So the overlap here I know is this polka dot region, right? Because if I shade up from this line, and I want to know which system of inequalities in graph are shown, which section or sections could represent all of the solutions to the system. The solution to the system is where they overlap, and that's going to be section R, right? So section R is going to be our correct answer. It can't be the other ones because they just can't be it. And again, I'm whining a little bit because I don't think the SAT did a good job of being accurate on the slope. So just a heads up, if it doesn't say it's to scale, the College Board could screw you over and you might have to look at other details to try to figure out which line is which. But in any case, we don't have any numbers here, so it's hard for us to know exactly what's what. But I will say that these two lines do look very symmetric in terms of the angle they form with the horizontal line. And I find that pretty, do you see how like this isosceles triangle looks like it has two like, similar, anyhow. Not to scale. In any case, I can still get the answer choice A. So if that scale is what threw you off, I get it. It's the SAT. You just got to play by the rules. You got to think there has to be an answer. They're going to be sloppy, but that doesn't mean you can be. 28 to 31. These are the grid-ins. A good rule of thumb, if you are not getting through this test, if you like didn't even approach any of these, didn't even get this far, remember you can always skip ahead to these even before you finish your multiple choice. So if the multiple choice starts to feel hard to you, you can always stop, skip the rest of the multiple choice and do these. I have some students too who will do these first, because if you guess on multiple choice, you have a much better shot of getting a point than if you guess on something that's open answer. So if you can do these just as fast, well, you could start with them and then you could guess the answer on just multiple choice questions, and maybe you have a 1 in 4 shot of getting them right. And then your score is going to go up. So that's another strategy that some of my students use. 28. In the xy plane above shows one of the 2 points of intersection of the graphs of a linear function and a quadratic function. So this is my linear. Remember, linear just means line, right? And a quadratic function is like a parabola. Yeah, so that's my quadratic. The point of intersection has coordinates VW. So what this is, guys, if you're looking for the coordinating SAT content area, this is linear and quadratic systems. We have a content video on that. We have some practice on those. You can also, when we get it done, we're going to be doing a polynomials and quadratic skills video, which will also relate to this. Quadratics and polynomials will be the name of it, probably. Look out for that, because we're going to talk more about what we learn about quadratics and things. The shown point of intersection has coordinates v, w. If the vertex of the graph is at 419, what is the value of v? So all they're asking is, what is the v? And here's what we know. I know that VW lies on this line, right? I also know that VW lies on this parabola. So if I can find the equation of the line and I can find the equation of the parabola, I know that this is the solution for that system. So that's my first thing that I'm going to do. I'm actually going to try to do this algebraically. The other thing, you can't look at multiple choice because this is open answers. So this is, we're just straight up. This does not look like the easiest ever grid in, but we're going to go for it, okay? First thing I want to do is find the parabola. Now we need to know vertex form. If you don't know vertex form, you're in big trouble on the SAT. Vertex form is y equals a times x minus h, quantity squared plus k, where h is our horizontal shift to the right, k is our vertical shift up, a is just some, like, I like to call it like a pseudo slope. It basically tells the parabola to get skinnier or to get wider, and that's about it. Those are our components. So I want to solve for this form using these 2 points, and this is how I do it. First thing I do is I plug in 4, 19, because I know that the h and k, the shift, right, is always a shift from 0, 0. Our original parabola, if I do y equals x squared, guess where that vertex is? That vertex is at 0, 0. So here my vertex is at h, k. Sometimes this is called vertex form because that's what it has. It has h, k, which is the vertex, okay? So I'm going to take my h and k and I'm going to plug it into this. And then what I'm going to do is I'm going to plug in the 0 and the 3 in for x and y, and then we're going to solve for this a, because that's the piece I don't know. So I'm going to write out first y equals a times x minus 4, quantity squared, plus 19. Next, I'm going to plug in 0, 3. So if x is 0, y is 3. So I go 3 equals a times 0 minus 4, quantity squared, plus 19. And now I just solve this down. Negative 4 squared is 16, so I get 16a plus 19 equals 3. I'm going to subtract. I get negative 16 equals 16a, and then I get a equals negative 1. Beautiful. That looks really normal, really lovely. So I get a equals negative 1. And now I'm going to just plug that in over here, and this is actually a very simple quadratic. Y equals negative x minus 4, quantity squared, plus 19. Okay, so here's my equation, and now I know this has to intersect with this line, and this line will, let's check out the slope of this line, and then we'll do slope-intercept form. We already have the intercept, which is nice. I know when x is 0, y is negative 9. So this is my 0, comma b. Remember, your y-intercept is the intercept in slope-intercept form. So if I just find the slope, I'm good here. So this is over 2 and then down -1. So from -1 to -9, this is a rise of 8, right? And from 0 to 2, this is a run of 2. So 8 over 2 is 4. So my slope here is 4. Okay. And I just did that by pegging it out and looking at the difference between this and this and this and this. You can use a formula if you like, but I sometimes just like to eyeball it and sort of look at these numbers and know what I'm going. I know it's an uphill, so I know it's going to be positive. So it's just positive 4 is our slope. So I get y equals 4x plus b, and again, b is -9, and I'm done. Now I also could have plugged in the 0 and then solved for y when x is 0. Obviously this goes away and y equals -9. So it's kind of redundant. But there you go. So now what I want to know is I want to know, where do these two intersect? Now here's the good news, everybody. You get to use your graphic calculator on this test. So one way that you could solve this, and you know you have to be able to fill in v in a grid, and so it's probably going to be an integer or something that's easy to write out, okay? So one way you could probably speed this up, and this isn't always going to work. Sometimes it's going to be kind of annoying and you're going to get a weird fraction or something that you have to do it to get it exactly, and it's going to screw you up if you do it with a graphing calculator. But nonetheless, I'm going to try this because I have faith that most likely, especially because this is the first one of the grid-ins, that this is going to be nice and even. So I'm just going to graph these two out on my little graphing calculator. Now, obviously, you can't use Desmos on the SAT. And I get here, my point is 6, 15. And on your TI or whatever, you can trace until you get to it. So I get 6, 15. So that means V. I need to make sure I put the right one. V equals 6, and I'm done. W, I don't exactly know what W is. Now, how do you solve this if you don't want to do it that way? Well, the other way you could do it is V is like X, right? So that means you want to solve these out for X. So you could plug in V and W into these if you wanted, or you could just solve for X between these two. And how would you do that? Well, you could set 4x minus 9 equal to negative x minus 4 quantity squared plus 19. You could then, at this point, ostensibly expand this, combine all your like terms, and find a single quadratic equation, and then you could solve that quadratic equation down. Again, at that point, if you have a calculator program that solves quadratic equations, you could do that. But as you can see, like, it's much faster if once I get both of these, I just plug them in my graphing calculator and I hit trace, and I try to find that intersection point. That's usually going to be a little bit faster because it's a grid, and I can kind of trust it's going to be probably an integer. It's probably an 80–90% chance it's an integer. If it's not, yes, then I'm screwed a little bit, and I probably have to go back and do this the long way. Thank goodness that usually on the SAT I have extra time in the calculator section, and I've got a boatload of time left over at the end. This is a pretty time-consuming problem, so if you do have problems with time, it's the kind of thing that you might say, hey, I realize this is a little bit involved. I have to find the equation for this line. I have to find the equation for that line. And then I have to synthesize the two together. I find that whenever we have these like solve for A and K problems, they can be very time-consuming. That's what I call these. A or K. Because here we're solving for like the A here, right? And then we're plugging stuff back in. So I can see that this is very involved. When you have these involved problems, sometimes they're the most time-consuming problems on the SAT or PSAT or whatever you're working on, so be aware. In any case, answer 6, and we're done. All right, 29. In a college archaeology class, 78 students are going to a dig site to find and study artifacts. Cool. The dig site has been divided into 24 sections, and each will be studied by a group of either 2 or 4 students. So we have 24 sections. Okay. This is a little bit arbitrary, but there you go. There's 24 sections. How many of the sections will be studied by a group of 2 students? So what I like to think of is we basically are dividing these out and visualizing this right here. We're either going to have 2 students, right, or we're going to have 4 students. So there's some number here. I'm going to call these groups small groups. We're going to have S small groups, and that would be the 2-person. And then we're going to have L large groups, and that would be the 4-person. And I'm going to create like a system of equations here, and I know that that's kind of where I'm headed, and I just have to figure out what are my variables, and that's what's kind of tricky. So here's what I know. I have 78 students going. If I add up all the students in the small groups and all the students in the large groups, and then all the students in the large group, or large groups, then I'm going to get 78. So let's talk about how we can represent these using variables. Well, if I say that I have S small groups, like let's say I had 2 small groups, then I would do 2 times 2. Let's say I had 3 small groups, I would do 3 times 2. So if I have S small groups, I'm going to do 2 times S, and that's going to give me the number of students in small groups. And I'm going to do the same thing here for large groups. I'm going to do 4L. So if I have 2S students in the small groups in total, 4L students in the large groups in total, but you can see how I can kind of draw it out, visualize it. That helps me wrap my brain around it if you guys struggle with these. I always like drawing pictures. It just opens up my mind. It helps me push forward in the problem if I can't quite see it right away. And this can be a little bit confusing. How many of the sections will be studied by a group of 2 students? So what I want to know is how many groups of 2 do I have, right? Oh yeah, and that's the number of small groups, right? If I had 3 small groups, that's S, right? So I want S. That's my need. Now here's the other thing I know. I know we have 24 sections. So I know that S, the number of small groups, and L, the number of large groups, sum to 24. And there is my system of equations. So we have 2S plus 4L equals 78, and S plus L equals 24. Those are our 2 equations, and I'm just writing the other one down here. And so here is my system of equations. Cool. At this point, if you are on the SAT, my favorite way to solve this at this point is to get out an equation solver. I use one quite a bit that I've talked about in some of my videos called AlgDOS. I downloaded it from ticalc.org. What's awesome about the SAT, at least as of February 25th, 2019, you are permitted on the SAT and the PSAT to use calculator programs. They haven't had any rules against them. Now, maybe in the future they will, so always be sure to double check before you go in for your test. I can't guarantee that whatever random date and time you are taking this test, they won't have changed the rules on you, and you are the student, not me. So you have to be responsible. But as of right now, that's how I would do this. And then how do we do that? Well, I just enter these into my calculator program. It solves it all down for me. But I'm going to show you how to do it the old-fashioned way, just in case you don't have that in front of you right now, or you want to do a little bit of review. But that's the fastest way to do this. I'm going to multiply this. I'm going to use elimination. Am I? I need to solve for S, so I want to eliminate L. Actually, no, I'm going to use substitution. So remember, isolate to eliminate. That's my trick that I use so that I don't isolate the thing that I'm not solving for and then accidentally give you L instead of S. That's one of the biggest mistakes that people make. So if I need to know how many sections will be studied by 2 students, I want to solve for S, so I want to isolate L to get rid of it. So I'm going to isolate L. I get L equals, and this is just part of my parentheses from before, L equals 24 minus S, and then I plug that in down here. 2S plus 4 times 24 minus S equals 78. And now I'm just going to do some more math. 2S plus 80 plus 16 is 96, minus 4S equals 78. And then we have 96 minus 2S equals 78. And then I'm going to add 2S to this side, subtract 78 from this side. That would be 20, but I'd be too short, so it's 18. Again, you can always use your calculator if this was hard. If you can't see that this is 18, please just use your calculator. Don't mess silly things like that up. It's not worth it. Just get out your calculator. There's no shame. I get 9 equals S, and that's my answer. And I'm done. And if I wanted to, I could then go back and double check things. This is what I usually do at the very end. I do 2 times 9 is 18, right? And then if that's 9, I've got 15 of these. So that's 4 times 15 is going to be 60 plus that is 78, and boom, there's my 78 students. So it worked. I can plug it in over here and I get 78. So that's looking pretty good. I also know that 15 plus 9 is 24, and that is my total here. So I'm good. I double check my work. That's just a system of equations word problems. So if you need more of these are called systems of equations word problems. We have those in the content section. You can go work on more of these. We have a little problem set for all of you guys to go crush your word problem knowledge, crunch it in, learn more and more and more, and practice, practice, practice. It's good stuff, okay? So these refer to the following information. So here they're giving us some formulas. So this is more nonlinear equation word problems. if you're wondering what content area this goes into. We're going to do some more vertex forms, some more polynomial stuff. So polynomial and quadratics is a skill section that's coming out soon. Or quadratics and polynomials. I guess the quadratics comes first. Quadratics and polynomials is the skills that you're going to need for this. But the content area is nonlinear equation word problems. Okay, so go check out nonlinear equation word problems in the content section if you need more of this. And we're going to go ahead and take a look at this. We've got these three kind of formulas here. We know that an arrow is getting launched upward with an initial speed of 100 meters per second. And I'm assuming it's going to like eventually get pulled down. Yeah, height. So this is the height equation. Do you see how the height equation, this is just a really fancy, if we subbed out x for t, do you see how this is just like some constants in front of an x squared term and then an x term, and then this is negative in front of the x squared term? Yeah, that's like y equals negative x squared plus blah, 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 right? That's just an upside down parabola. So I can see here that my height is an upside down parabola, and that's very common on these kind of height questions. So I just familiarize myself a little bit. What is the maximum height from the ground? The arrow will rise to the nearest meter. So this is just talking about the position time, the height function, right? Or maybe the position speed. This could also potentially model it. But I want h, the height, right? I want the maximum height, and so we need to find h as the height. Yeah, so I want to maximize h. Remember, whenever we have maximums in equations, it's usually the maximum y value, right? Do you see how h is in the y position, so to speak, right? We're used to seeing quadratics that look like this. Y equals like x squared, blah, 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 right? It's the same thing. It's just we have h instead of y. But basically the same thing. If I want to maximize h, and I know just from looking at this that a bunch of these are constants, right? G is the acceleration due to gravity, 9.8. I can actually just fill this in with that 9.8 really fast. And I can rewrite this h equals, now what is v? Where v sub 0 is the initial speed of the arrow. So the other thing that I need to know is v sub 0 is the initial speed of the arrow. It says that the initial speed is 100. So I actually can take that out and make this 100t. And I can fill that in. And then we have this g here. And again, g was 9.8. So I can just fill that in, right? And this is going to start to shape up. I think you guys will see when I plug these in. I like to call this kind of question like function as a model. So keep your eyes open. I might do a skills video on this, meaning that SAT doesn't necessarily call them this, but this is what I would call this kind of problem. And they're definitely on the SAT. Like I said, nonlinear equation word problems is really where they show up in the content, but I think this is really particular in that they give you a bunch of formulas and then you have to plug into those formulas from a paragraph to kind of decode what they've given you and realize, oh, this is just a y equals x squared equation, but instead of y, we use h, instead of x, we use t. So it's much simpler than it looks. And so now let's get back to finding my maximum height. Remember, my maximum height of an upside down parabola is always the vertex. Which value on that vertex? It's the y value of the vertex, right? It's this. The y value is always the maximum. So I want to find the maximum h, which is the y value of the vertex. How do I find the y value of the vertex? Well, if I have this here, there's a couple of different ways to find the vertex, depending on what form we have. So I'm going to rearrange this so it looks a little bit cleaner. And I'm going to maybe do 1/2 of 9.8 just to clean up that 9.8 so it looks a little bit nicer. Times 0.5, I'm just using a calculator, 4.9. So this is negative 4.9 t squared. So I get h equals negative 4.9 t squared plus 100t. Okay, so this is my quadratic all cleaned up, this guy over here. I want to find the vertex of this. The fastest way to find the vertex, when I have it in, this is what I would call like ax squared plus bx plus c form. To find the x value of the vertex is to take negative b over 2a. And this is just something you can memorize. If you have negative b over 2a, that's always the x value of the vertex. And then you can plug in that x value of the vertex into the t's here, like the x, right? Remember, t is like x. And then you can solve for h. And that's going to give you your highest h or your y, your topped out value here, okay? So I know that's a little bit confusing. For whatever reason, it's easier to find the x value of the vertex most of the time than it is to find the y value of the vertex, even though usually you're solving for the maximum or the y value. And I'm using x and y interchangeably with like h and t because I think it's a little bit more intuitive, because that's what you guys learn when you learn quadratics. In any case, again, the x value of the vertex of anything that's in this form, right, which this is technically in this form, the c is just 0, right? We're going to do negative b over 2a. So negative b over 2a is negative 100 over 2 times negative 4.9 is just negative 9.8. I'm just going back to what I used to have. So this is the x value of the vertex. So again, I'm going to get out my calculator, and I can get rid of those negative signs and just do 100 divided by 9.8. And that gives me 10.2. And I'm just going to round. I'm not too worried about, like, because I'm pretty sure this is going to say to round to the nearest meter. Yeah, I'm going to round to the nearest meter. So I'm going to keep a 10th decimal. I always go 1 extra decimal versus what they want me to round to, but that should be good. And that was 0 something anyway. So 10.2 is my x value of the vertex, or my t value of the vertex, essentially, right? Because again, I'm just saying x value because that's what like this position is. This is like an x, at least what we traditionally think of where the x would be. The t is that. So I know 10.2 is going to be t, and now I get out my calculator again, and then I just plug in t, and then I solve for h, okay? So I'm going to do this, and then I'm going to square it. So we're going to square that. And then plus 100 times this. So 100 times this, I just move this over twice, right? Okay, so maybe I need to be a little bit more precise. I'm going to be a little bit more precise here. 100. I'm going to find a couple more decimal places just because I realize that I'm going to be multiplying this by 100. Oops. So if I do 100 divided by 9.8, again, I get 10.2040. So I'm just going to write out those places so that when I multiply by 100, I get 1020.4. So this is 1020.4, right? When I multiply by 10, I'm just trying to be a little bit more precise just in case that rounding gets me into trouble. It's probably overkill, but. So this, I'm going to square this again. And then I'm going to multiply this times 4.9. And I get that. So I get 510.2. And then from 510.2, this is going to become negative, right? Because it's had this negative sign here too. So I did the 4.9 times that thing squared. I get negative 510.2. And now I'm going to add that to my 1020.4. So and then I'm going to subtract 510.2. And I get 510.2. So that's kind of interesting. It's actually the same number as the thing that I'm subtracting. And I know some people who have actually messed this up and they didn't do the subtraction, but they still got the right answer because those two numbers happen to be the same for some reason. I don't totally understand all the math of it, but it's going to be 510 meters. Ta-da. So a little bit involved, a little bit confusing, but essentially all we're trying to do is find the vertex of this parabola. How else could you do this? Well, you do have a calculator. You could just graph this out and trace to the highest y value on this parabola to find that vertex. That's another way that you could have done this. Again, I can do it mathematically over here by doing opposite of b over 2a. Another way I could have done it, I could have seen that this could easily have been turned into a factored form and said, okay, that's going to be t times negative 4.9t plus 100. And I could have said, okay, this means t equals 0. Or this means t equals 100 divided by 4.9. Because I'm setting each of these things equal to 0. And then I would know that the x value of my vertex would be the average of these 2 points. So I'm going to average 0 and this. And then that means I'm taking 100 and dividing by 9.8, et cetera, et cetera. And then I get back to the same thing. So essentially what I'm saying here is that if I factor this out, if I have something in factored form, the easiest way to find the x value of the vertex is to average the x value of the zeros. So again, just to repeat what I'm doing here, if I find the zeros, x minus a and x minus b, and I see, oh, that's like my a and that's my b, right? The x value of the vertex is the midpoint or the halfway point, the average of my a and my b, if my a and my b are the x values of my zeros, right? If this is my, who knows what this is, but wherever my coordinate plane is, if this is my a and this is my b, The average of my two zeros is always where the vertex is because these are always symmetric, right? So I can use symmetry to find it. That's another way I could have found the x value of the vertex. The final way I could have found the x value of the vertex would be to complete the square, which is like my absolute least favorite ever way to do this. The College Board does it all the time on Khan Academy. I think it's the biggest waste of time ever. But if you want to complete the square, you can complete the square, or there's some questions on the SAT that completing the square might be the best way to do it. Maybe once in a blue moon. But I would say 8 out of 10 times you can avoid completing the square, and it will be faster to avoid completing the square. And some of you are like, what's completing the square? And if you're like that, you know what? Don't worry about it for now, but we will go over it eventually in our quadratics and polynomial skills section when we get to that video, which eventually we will. In the meantime, check out nonlinear equation word problems. You can check out some more of these. And remember, you've got to know this vertex stuff. I do cover this in must-know formulas in our YouTube video. So if you want to go over this vertex stuff, must-know formulas, our YouTube video definitely hits on that. So go check that out too. That's a good one. There you go. Thumbs up. Number 31. How long will it take for the arrow to reach its maximum height to the nearest tenth of a second? So this is interesting because we have 3 equations here, and you know what, you guys? You absolutely do not at all need this one or this one. Because from question 30, I discovered that the maximum height was 510.2. If you screwed up question 30, that might be why you got question 31 wrong. To figure out how long it will take the arrow to reach this, all that is the x value of the vertex here, right? Because what is this? Again, when I fill in all the information from down here into this, I get this lovely equation right here, right? And I can clean this up. This translates into this. Why does it translate into this? Some of you might be asking if you didn't watch the last video, which maybe a lot of you did, but some of you didn't. If you didn't watch that last video, here's what we filled in. We filled in the 100 meters per second in for initial speed. Guess what initial speed is? That's v sub 0. How do I know that? Because it says it down here. V is the initial speed of the arrow. Boom. So that told me that that's what v sub 0 is. So I fill in v sub 0 with that 100. So that's 100t. That's where this 100t comes from. Negative 1/2 gt squared. Guess what g is? G is 9.8 meters per second squared, and that's g is the acceleration, and that says it right here. So then I just plug that into the g right here, and then I do 1/2 times that, and that's how I got the negative 4.9. So this is just the same darn thing as this, but this is a little bit easier to digest because it just looks like a quadratic equation, right? This looks super crazy scary. Give me a nightmare. You plug in a couple of things from down here, boom, and this turns into a really nice, pretty quadratic, and it's not so bad. And if that was a little bit confusing for you, I encourage you to go back to the beginning of 30. I do it in a much slower, more methodical way. I'm assuming you got 30 right. If you got 31 wrong, and you didn't hear my whole explanation already, so I assume most of you are probably either going over both of these, or you already knew that much at least. So now I know that the maximum height is 510, right? So what t gives me that 510? Well, I solved for that in the last problem, actually. That was just the opposite of b over 2a, right? That was the 100 over 2 times negative 4.9, right? And then negative 100, I'm sorry, over negative 9.8. And then the negatives cancel, and I get 100 divided by 9.8. And so all I have to do here is just divide 100 by 9.8. And maybe I kind of already did this math, but I don't have it out because I didn't realize they were going to ask me for this. So I did this on my calculator a second ago, but yeah, 10.2 to the nearest tenth. Yeah, 10.2. And this says of a second, so I'm just going to triple check that this is in seconds. Oh yeah, that's meters per second. Yep. And this is per second squared. I'm just making sure that all my units over there were in seconds and that this isn't a trick question because otherwise it seems so silly easy after I did this problem and I needed this information in order to get this information. So like, how the heck? But maybe you did this all on a graphing calculator and maybe you just looked this up. And if you did, that's fine too, because this is the x value and this is the y value. They're just asking for the x value and the y value of the vertex. That's all 30 and 31 are. Really simple problems that are just asking for the vertex. The vertex is your friend on the SAT. The SAT loves to ask vertex questions, so make sure you know how to find the vertex of a parabola. I have 3 fun ways to find it. I go over those, I'm pretty sure, in our Must-Know Formulas YouTube video, which you can find on our course. Must-Know Formulas for the SAT. This video, guys, I go over vertex stuff in here. This is circle sectors, but if you skip over here, Vertex formula fun right here. Go to about 5 minutes in, right here on Must Know Formulas for SAT Math. In this YouTube video, I will break these things down for you. So if you missed this because that Vertex stuff threw you off a little bit, this is some really good content for you guys to review. I didn't make another video because it's already here. I already did it in a YouTube video, so we just stuck it on the course. Obviously, we have lots more tips that aren't on our YouTube, and that's why you're here. But there you go. You can watch that, review that right there, and that's going to go through sort of your fun ways to find the vertex on a parabola. There's lots of different ways, depending on what kind of input information you have. Some ways are faster than other ways. You can also always graph this, right? Once I get this up, I know that the h is essentially like a y, right? I know the t is essentially like an x, so I can graph this as y equals negative 4.9 x squared plus 100x. This is just a parabola. See how simple that is? And find the vertex. That's all you have to do. So hopefully this made sense to you guys. Hopefully it wasn't too much. And that's it for the PSAT. You did it. It's the end.